A magnitude 15 earthquake has the potential to completely destroy our planet and evaporate all the water in a matter of seconds, leaving Earth uninhabitable. Over 500,000 earthquakes happen annually, but none have a magnitude of 15. 90% of quakes occur in the terrifying Ring of Fire zone located around the Pacific Ocean. The ground there is like jello. It shakes almost constantly. The most powerful earthquake to have ever struck Earth had a magnitude of 9.5. That much power can lengthen or shorten the day. But there's probably an earthquake in the confines of your own home now caused by a speck of dust landing on a table. But it has a power of negative 15 magnitudes. Earthquakes happen when tectonic plates move. They're like Lego pieces that are not properly secured, and when they move up, down, or hit one another, the ground also moves, triggering earthquakes. This tectonic energy acts like a battery. It stores energy for a long time, up to 500 years. When this stored energy is released in a sudden burst, the consequences are horrifying. Even the strongest structures submit to this relentless force that leaves a trail of destruction in its path. In some instances, earthquakes can even trigger tsunamis, amplifying the chaos. Such a crazy amount of power can split the ground open and cause severe damage. The strength of an earthquake is measured by the Richter scale, but now it's being replaced by the moment magnitude scale. When there's an earthquake, we hear about how strong it is. It's usually from 1 to 10. Luckily, we haven't had a Richter scale earthquake yet. The most powerful earthquake to have ever happened in modern history occurred in Chile in the 60s. It was around 9.5 on the Richter scale, and it altered Earth's rotation and messed up the length of the day by around 2 milliseconds. It also triggered a massive tsunami and affected a vast area of 155,000 square miles. The Richter scale doesn't actually have a limit. Still, anything above 25 doesn't need measuring, because if that ever happened, we would simply turn into dust, and nobody would care to measure this disaster. As we said, the strongest earthquake had a magnitude of 9.5. If this magnitude had been just 0.5 stronger, it would have created a ruptured line 2,174 miles long. That is almost 7 times the size of Wyoming. A magnitude 11 earthquake would create a crack halfway around the world. Massive tsunamis would hit coastal areas, destroying everything, and Earth would get into a massive environmental crisis. If you love hiking, you would have new mountains to explore, created by the terrifying earthquake. Even the temperature would increase because of volcanic eruptions and the resulting greenhouse gases. It would turn our planet into a hot oven. The safest places would be far away from any buildings, seas, oceans, and mountains where there would be a low chance of a landslide. Countries unprepared for earthquakes would be totally destroyed, and cities would turn into piles of rubble and dust. Going up on the Richter scale would only make things worse. But don't worry, an earthquake of that power is impossible. Earth's crust doesn't have enough energy to produce such earthquakes. But there is something that has much more power and can produce mega earthquakes. Asteroids are powerful enough to destroy our planet, as we all know from the dinosaur era. That asteroid was around 6 miles long, and it caused massive damage to the planet. It triggered earthquakes that shook the ground constantly for months. These terrifying quakes were about 50,000 times stronger than the Chile earthquake. They also triggered a tsunami that was 30,000 times more powerful than the Indian Ocean tsunami. And the latter was one of the most devastating tsunamis to have ever struck Earth. The earthquakes caused by the asteroid had a magnitude of 11, making it the most powerful and scariest natural disaster ever. And let's hope it stays that way. The Indian Ocean tsunami affected only certain areas of the world. Meanwhile, the asteroid tsunami affected every part of the world and had 33-foot-tall waves. Even if you had traveled to the most remote place on Earth, you wouldn't have been able to hide from this Grim Reaper. A 15-magnitude earthquake wouldn't be 15% stronger than the Chile earthquake. The scale doesn't work like that. It would be around 100 million times more powerful than a 9.5 magnitude quake. It could make all the water on Earth evaporate, leaving us devastated and without any H2O to survive. All ecosystems would collapse, all food chains would be broken, and only some super strong bacteria would probably survive the impossible. That is only a fraction of the frightening things that could happen. The ocean is like the AC for our planet. Without it, Earth would be super hot. The ocean also serves as a shield from the sun's powerful rays. It acts as a heat absorber and cools Earth. Scientists think that the most dangerous thing would be the inability of Earth's crust to survive the violent shakes of the 15-magnitude earthquake. If our planet miraculously survived and didn't turn into dust, there would be massive openings in its crust. The ground would become gelatinous. It would randomly move up, down, left, and right, and no building would survive that. Our civilization would be brought back to the Stonehenge era. Tectonic movements like this are devastating. A similar thing happened in Japan when tectonic plates moved 165 feet from each other and then snapped back together, creating a 9-magnitude earthquake. No place on Earth is immune to this bone-chilling natural phenomenon. Still, certain places have higher chances of being destroyed than others, like the Ring of Fire, where 90% of earthquakes happen. This is a place where earthquakes are almost everyday occurrences. The Ring of Fire is located in the Pacific Ocean. It forms a ring around the continents that surround the Pacific. There, several tectonic plates meet, creating highly unstable ground. To make the problem much more terrifying, 75% of active volcanoes are located in this area. 90% of dormant volcanoes are also there, making this place extremely dangerous. Scientists carefully study this region to find a way to predict when the next earthquake might strike. The Ring of Fire is not the only place at risk of earthquakes. In California, along the San Andreas fault line, 2 tectonic plates have been storing power for more than 200 years. The San Andreas Fault is 715 miles long and has the potential for a massive earthquake. This region has its fear of violent earthquakes like the one that happened in San Francisco in 1906. It had a magnitude of 7.8 on the Richter scale. Scientists' predictions are terrifying. They say that the chance of a 6.7 magnitude earthquake is very high in the area. If all hell starts to break loose, you should know how to survive. Avoid anything that might fall on you, like windows, closets, or unstable ceilings. The official phrase from emergency experts is drop, cover, and hold on. Stay low to the ground. Hide under something stable like a table, and remain there until the shaking stops. Make sure to stay in your shelter for another minute or two, just in case there are aftershocks or loose debris. Use your nose and smell for gas. If you do smell it, don't turn the lights on or do anything that might ignite it. Stay strong and be safe.
So, since 2000, the world has been hit with more than 1,700 earthquakes with magnitude greater than 5. Many happened around the Ring of Fire, located around the Pacific Ocean. In North America, the biggest threat is the San Andreas Fault Line, which can create an earthquake of a magnitude higher than any other, earning it the spine-tingling nickname, the Big One. The potential destruction of California is a terrifying prospect that could have unimaginable consequences. But the Big One is just the beginning of what's to come. Bad news! Scientists have predicted an earth-shattering event that will occur in 2030. Like it or not, there's a 70% chance that we'll experience the Big One, and it will be an earthquake with a magnitude of 6.7. The San Andreas Fault Line will cause the Big One, but what is scary is that we can't predict it. On the other hand, a massive earthquake occurs every 100 years. This means there's always time to prepare for a natural disaster. If we traveled back in time, we'd see a few significant earthquakes like the ones that wiped out San Francisco and Fort Tajon. Buildings made a long time ago are not quake-proof. They will collapse. Even if they survive, you should not enter them. But buildings are not the most dangerous part. You should watch out for electrical lines and gas pipes. Your hill house might be lovely, but it is extremely unsafe. During quakes, the hill can turn into a massive landslide that will destroy everything in its path. Say goodbye to road trips because all the roads will be ruined. You should have some spare water and food since you won't be able to go to the supermarket. This disaster won't be cheap. It will cost the U.S. around $200 billion to recover from the quake. At least the earthquake will not trigger tsunamis. But there's something it can cause more damage than the big one. The notorious Cascadia subduction zones start in California and ends up all the way in Vancouver, Canada. The San Andreas fault line is nothing compared to this zone. It can wipe the whole coast off the face of the Earth, an example of hyperbole. Subduction zones are tectonic plates forced to be one under the other and constantly pulling apart. One is called the North American Plate and the other is the Juan de Fuca Plate. Zones like these are not to be messed with, since they are terrifying hotspots for earthquake activity and extremely dangerous because they cause massive underwater quakes. But they are underwater, so what can they do to us? Well, they can cause giant tsunamis, flooding cities, and destroying the coastline. Right now, the most active zone is the Ring of Fire. The Cascadia zone might be less active, but it is like a sleeping beast that can wake up and destroy everything in its path, causing a groundbreaking earthquake. The last time all this stress was released was in the year 1700. Unlike the San Andreas quake, this one will cause massive tsunamis and much bigger shocks. Let's hope you'll be camping in an open field at that time, because most buildings and bridges will likely be destroyed. Also, be ready for the aftershocks, as they'll be devastating. Nature won't be spared either. Landslides will change animals' habitats. Even our homes will be changed forever. Luckily, there is a light at the end of the tunnel, and scientists are doing everything they can to ensure our safety. New rules are implemented. Every new building must be able to withstand massive shocks. They're developing modern warning systems, and every new infrastructure must follow strict quake-proof guidelines. The Juan de Fuca and the North American plates are locked together, but they won't stay like that forever. When they unlock, get ready for a massive shake. The closer you are to the epicenter, the more damage you'll experience. But even if you are lucky to be far away, you may still feel the ground shaking for some time. Now, if we compare the Cascadia subduction zone and the San Andreas fault, we'll see how much more dangerous the Cascadia zone is. In 1994, there was an enormous 6.7 magnitude earthquake in the Northridge area, close to the San Andreas fault. Sadly, many people didn't make it, and some were injured. Back then, buildings were not strong and earthquake-proof, and many of them were damaged. The Cascadia subduction zone can potentially cause a magnitude 9 earthquake. A magnitude 6 quake has the power of around 44 million pounds of dynamite, but a magnitude 9 has the power of 44 trillion pounds of dynamite. The strongest ever recorded quake was in Chile. Its magnitude measured 9.5, and it destroyed most everything. So let's say you've survived the quake, but the struggle is far from over. Soon after, a massive tsunami will strike, with waves that might reach up to 100 feet in some areas. That's so unlike the San Andreas earthquake, which can't produce any significant waves. So say goodbye to your beautiful garden, since salt water will destroy trees and plants, changing the environment for a period of time. The only positive thing will be you won't need Halloween decorations, because all those dried-out trees will resemble a ghost forest. The combination of waves, quakes, and the sheer size of the area will make this natural disaster much more dangerous than any caused by the San Andreas fault or the so-called Big One. A quake similar to this happened around 300 years ago. Many more have been recorded in the past 3,500 years, proving that they continually occur every 400 to 600 years. So, technically, we have around 100 to 300 years before the next big one hits. We still have no idea how exactly the Cascadia subduction zone works, because we discovered it in 1970. This zone is super scary because it can cause big earthquakes. It was found by accident when researchers studied the Ring of Fire. They wanted to know if this area had caused any trouble in the past years, and the proof was under their noses. In Washington, there is a horror forest where nothing has been growing for years. When researchers tested the soil, they found a tremendous amount of salt. They put two and two together and concluded that a massive tsunami had been the reason. Experts still didn't know when the forest was destroyed, But Japan kept records of a gigantic earthquake that had a similar effect. It was the one that happened in the year 1700. There is a 1 in 3 chance that the next one will occur in 2050. You must know how to survive the Canadian earthquakes and make it out unscathed, so listen carefully. Those who live in this area have almost no experience with earthquakes like this one. Surviving the quake is relatively easy, but the tsunami coming afterwards is the real danger. After the shake, find the highest ground and go there. Only bring the essentials, like food and water. Yeah, leave your baseball card collection at home. After the first hit, don't try to go down. Seismologists say that most likely there will be a few more waves, and they have proven this. On the 22nd of May, 1960, seismologist Jerry Eston and his 4 friends went to Hawaii to see an expected tsunami that was to happen around midnight. They set up their gear on Wailuku Bridge with an escape route planned. This bridge had been destroyed in the previous tsunami, but the new one was much taller and better. After midnight, the water was 4 feet above the average level. The second wave hit a half hour after midnight, and the water rose another 9 feet by 1 a.m. The water started going down and dropped by 7 feet, but the horror was far from over. Next, they saw a wave that was around 20 feet tall. This shows us that tsunamis are unpredictable, and we should listen to experts to stay safe. The strongest earthquake ever to strike east of the Mississippi River that happened over 200 years ago was never over, according to some scientists. Most earthquakes last seconds to minutes, and the official record breaker so far is a silent one in Sumatra that was going on for 32 years. This slow slip event triggered a massive quake and a tsunami. So if it's true that the New Madrid earthquake is still sending aftershocks, we'll have a new top name for this sad list. The earthquake started in December of 1811 with a powerful quake in a sparsely populated part of northeast Arkansas. They felt the shaking almost 1,000 miles away in the White House, and the tower bells were ringing in Boston, even further away. It even made the mighty Mississippi flow backward for a few minutes over new waterfalls formed by shifted ground. The town of New Madrid, Missouri, completely disappeared in the disaster. The Earth wouldn't stay still until the end of January the following year, when things got serious again. A massive quake hit, this time near the junction of the Ohio and Mississippi rivers, right in the Missouri boot heel. Geologists believe it was a rupture on the New Madrid Fault, putting even more strain on the nearby Reelfoot Fault. Just when people thought it couldn't get worse, another 2 weeks of trembling passed, and the Reelfoot Fault snapped deep beneath New Madrid. Down in Tennessee, about 15 miles south of New Madrid, the ground uplift created Reelfoot Lake. Steamboats were chugging along the river, with thousands of trees floating and acres of woods torn apart by the quake. In St. Louis, Missouri, which is 160 miles away, buildings were badly damaged, and chimneys fell in Cincinnati, Ohio, 400 miles away. People all the way in Montreal, Canada, over 1,000 miles away, felt the earthshake. Seismologists have registered about 200 small earthquakes in the New Madrid seismic zone every year since 1974. Some researchers believe that up to 30% of those were aftershocks from those big quakes back in 1811 and 1812. In parts of the U.S. where there's not much tectonic action going on, these aftershocks could keep rumbling for years, maybe even centuries, after the big ones hit. Aftershocks are the Earth's way of releasing all that built-up stress from the main quake. When the ground shakes from the first earthquake, it puts a lot of pressure on the rocks nearby. And when those rocks can't take it anymore, they crack, causing even more shaking. That's the aftershock. And they can be pretty intense, especially right after the main quake, but weaken over time. Not all scientists agree that contemporary earthquakes have to do with those from 200 years ago. We mostly associate faults with those lines where Earth's plates meet. But there's a whole network of those right under the center of the North American plate. They're like relics from 750 million years ago, when North America was part of a supercontinent called Rodinia. When Rodinia started to break up, It left behind these rifts, weak spots in the Earth's crust that run deep beneath the modern Midwest. It could explain the earthquake action. An international team of geologists decided to take a fresh look at 3 major earthquakes that shook North America and end the debate. They used a new math method called the nearest neighbor. It says that if earthquakes are too close in space, time, and magnitude to be independent background events, then one is assumed to have triggered the other. Depending on how you look at the numbers, somewhere between 10 to 65% of the recent quakes in the region could be aftershocks of those historic earthquakes. And a huge quake that hit Charleston, South Carolina at the end of the 19th century might explain up to 72% of the earthquakes in the area since then. But not all places are the same, so the scientific debate continues. In 1774, British explorer James Cook noticed a glow in the distance. It was the volcano of Mount Yasur in Vanuatu. This bad boy had been spewing lava and ash ever since, and it's quite likely that it's been doing that for way longer. The volcano has been sitting at alert level since October 2016, which means things are really unsettled around there. They've even marked off a 2,000-foot radius around the crater to keep people safe. There have been low to moderate outbursts, shooting out ash, gas, and steam, and some bigger blasts throwing stuff outside the crater. Satellite images have picked up on some hotspots of sulfur dioxide plumes, showing that Yasur is still cooking up a big storm down there. Stromboli, one of the volcanic islands near Sicily, officially has the Guinness World Record as the longest continuously erupting volcano. It has been putting on a fiery show for over 2,400 years straight. Ancient sailors nicknamed it the Lighthouse of the Mediterranean. Most of the time, Stromboli's just spitting out spatter, but every now and then it throws in some lava flows or shoots up some moderately high fountains. Sometimes you might even catch a glimpse of steam-driven outbursts. Over 200 million years ago, the world went through a major makeover, with not 1, not 2, but 4 massive volcanic eruptions changing the game. It all happened in Rensselaer, a large chunk of island that used to be a supermassive volcano stretching across what's now British Columbia and Alaska. This volcanic activity might have helped dinosaurs grow from cat-sized critters into giants we saw in Jurassic Park. It kicked off a 2-million-year rainy season. It made the whole world hot and humid, and the dinos just loved it. Researchers dug deep into sediment layers beneath an ancient lake in China to uncover these secrets. They found traces of volcanic ash and mercury, clear signs of those epic eruptions. There were carbon signatures showing huge spikes in carbon dioxide levels, making the atmosphere toasty and the rain pouring down. It all happened in 4 separate pulses, each triggered by those monstrous volcanic blasts. There's a spot in a national park not too far away from Sydney, Australia, where a fire has been raging deep underground for at least 6,000 years. They call it Burning Mountain, and it's a coal seam fire, burning its way through a layer of coal beneath the Earth's surface. Once these underground fires start, they're pretty much impossible to put out. This ball of fire is up to 30 feet wide and extremely hot, but there's no flame, it's smoldering. The fire has been creeping along at a pace of about 3 feet per year. A local farmer first spotted it in the 19th century and thought it was a volcano. The people who have lived here for ages believe this place is sacred. They've used it for cooking and crafting tools, and tell that it started from a widow's tears or the torch of a hero. But experts think it could have been a lightning strike or coal heating up like a summer barbecue from the interaction with oxygen. Some say it might have been burning since before the dinosaurs roamed the Earth. No one knows exactly how long this mountain will burn or in what direction it'll move. Right now, the coal has enough oxygen to burn for centuries or even millennia without human intervention. The fire is heating up the mountain like a giant oven, making it crack and crumble, inviting in more oxygen to feed on. Even if humans decide to take action, these coal seam fires need truckloads of water and liquid nitrogen to tame them. Several years ago, Explorers noticed that the smolder was creeping close to a cliff overlooking a little river, and depending on what the coal seam decides to do next, we could see some dramatic changes here in the coming decades. There could be flames with much more heat, or the coal seam could go deep, extinguish itself, and smolder out.
An earthquake in Indonesia began in 1829 and lasted a mighty 32 years. It reached its climax in 1861 and hit a magnitude of around 8.5. It was caused by the tectonic plates below the island slowly clashing against each other. Researchers discovered that the quake had been building for some time after analyzing the coral in the area. They found it was being periodically exposed to the open air. That was caused by the gradual earthquake moving the land up and down. Scientists call these decades-long silent earthquakes slow slip events. A single lightning bolt can warm the air to around 54,000 degrees Fahrenheit. The heat makes the air expand quickly, creating a shock wave or boom, which we know to be thunder. There are close to 3 trillion trees on Earth. That translates to roughly around 422 trees for every person. Before humans, the number was nearer to 6 trillion. Almost 70% of the Earth's surface is covered by water, which on average is around 2.5 miles deep. 97% of Earth's volcanoes lie underwater, as well as the mid-ocean ridge, a massive mountain range that is over 40,000 miles long. Humans have mined around 190,000 tons of gold from the planet. Experts predict there is around 20% still left to be mined, but this figure is constantly changing. The world's largest active volcano is in Hawaii. Called Mauna Loa, it's over 2.5 miles above sea level. Given that most of it is underwater, the volcano's summit is a staggering 11 miles from its base. That's the same length as over 160 football fields. The highest ever recorded temperature on Earth was a sweltering 136 degrees Fahrenheit. It was recorded in El Azizia, or modern-day Libya, on September 13, 1922. The lowest temperature was a chilling minus 129 degrees Fahrenheit, recorded at Russia's Vostok station in 1983. Earth is the 5th largest planet in the solar system, behind Jupiter, Saturn, Uranus, and Neptune. It has a circumference of roughly 25,000 miles, and it would take the average person around 8,300 hours to walk around the face of the Earth. The separation between Earth's land masses would make such a trek almost impossible, though. It takes 365.25 days for the Earth to orbit the Sun. Because our calendar years only have 365 days, we add an extra leap day every 4 years to make up for the difference. Russia is the largest country on the planet, with a total area of about 6.5 million square miles. It encompasses more than 1/8 of the Earth's inhabited land area, but still has a relatively small population given its size. Earth is the only planet with one moon. Mercury and Venus have no moons, while every other planet has 2 or more. Earth is over 4 billion years old. Scientists calculate this by looking at the planet's oldest rocks, as well as meteorites that have crash-landed. They used meteorites as they were formed at the same time as Earth, when the solar system was forming. The ground we walk on is basically recycled. The planet's rock cycle turns igneous rocks to sedimentary ones, then transforms those into metamorphic rocks, and back again. Like Earth, our moon also experiences earthquakes. They're less common and intense than the ones we have, and are caused by tidal stresses. A tidal stress is basically the relationship between the gravitational pull of the moon on the Earth and that of the Earth on the moon. Despite being the 5th largest continent, Antarctica holds 70% of the planet's fresh water and about 90% of its ice. Bangkok is the most visited city in the world, boasting 23 million visitors in 2019 alone. Paris, London, Dubai, and Singapore make up the other cities in the top 5. The lowest layer of Earth's atmosphere is called the troposphere and is the reason we have weather. Sunlight heats the planet's surface, which causes warm air to rise up to the troposphere. This air then expands and cools as the air pressure decreases and sinks down, where it is then warmed by the Earth again. Coral reefs are the largest living structures on the planet, with some even being visible from space. Coral reefs hold the most species per area of any of Earth's ecosystems, even more than rainforests. Earth got its name around 1,000 years ago, and it comes from the German word meaning the ground, but there's no evidence to show who actually named it. Of all the planets, Earth is also the only one which is not named after a Greek or Roman deity. The deepest point of the ocean is the Mariana Trench. It's a whopping 7 miles below sea level. Coastlines cover about 20% of U.S. land, but are home to more than 50% of the U.S. population. The Earth isn't actually a sphere. It's more like a squished ball that bulges at the equator. The bulge is caused by the force of the Earth spinning, which makes the north and south poles slightly flat. The Earth spins on its axis, which is basically an imaginary straight line. Earth has seasons because the axis is tilted, causing the sun's rays to hit different parts of the planet more directly, depending on the time of year. If the sun was as tall as a standard door, the Earth would be around the size of a nickel. The Earth's rate of rotation is gradually decreasing. It's happening so slowly that it would take as much as 140 million years for the length of a day to increase to 25 hours.
Get equipped for any season with brand new Brightside merch. Click the link and grab your print.
The biggest animal on Earth is the Antarctic blue whale. It can reach lengths of 100 feet and weigh up to 400,000 pounds, which is around the same as 33 elephants. The temperature at the center of the Earth is around the same as the surface of the Sun, at almost 10,000 degrees Fahrenheit. Earth is around 10,000 times older than humans. Earth is around 4.5 billion years old, whereas humans have been around for, at most, 450,000 years. There are around 34,000 known species of fish. The actual number is way higher though, as a whopping 95% of our oceans still haven't been explored. America's Route 66 is longer than the journey to the Earth's core. The distance to the core is roughly 2,000 miles. Route 66 is almost 2,500 miles. The Earth is made up of 3 main components: the crust, the mantle, and the core, which is divided into the outer core and the inner core. Scientists have estimated that there are around 8.7 million species on the planet. Out of this, between 1 to 2 million of these species are animals. But roughly 86% of land species and 91% of fish have yet to be discovered by humans. Ancient astronomers used to think that the Earth was the center of the universe. For 2,000 years, they believed the Earth to be static, while other bodies traveled in orbit around us. In 1543, Copernicus published his sun-centered model of the solar system. Earth is the densest planet in the solar system. The density varies across its different crusts, but the planet's average density is just over 3 ounces per cubic inch. Mount Everest is the highest point on the planet. Its peak is the highest altitude above sea level at around 5.5 miles. Each year, 1 septillion crystals of snow fall on Earth. That's a trillion snowflakes. Snow covers about 31% of Earth's land area each year. Of Earth's water, only around 3% is fresh water. The other 97% is salted. Of that 3%, about 2% is frozen in ice and glaciers. So, less than 1% of the planet's fresh water is actually in lakes, rivers, and underground. The world's largest inland body of water, or lake to us normal people, is the Caspian Sea. It has an area of 140,000 miles squared. The world's deepest lake is Lake Baikal in Russia and is 5,300 feet deep. Earth's atmosphere is roughly 78% nitrogen and 21% oxygen, with small amounts of water vapor, carbon dioxide, and other gases. No other planet is believed to have this much oxygen, which explains why Earth is the only planet where life has been discovered so far. Apart from the Moon, There are 2 asteroids in co-orbital orbits with Earth, sometimes called Earth's second moon. 3753 Cruithne is an asteroid that looks like it's following the Earth in orbit, but it's actually following its own path around the Sun. 2002 AA29 is another asteroid which makes a horseshoe orbit around the Earth that draws it close to the planet every 95 years.
There is a powerful force hiding underground where tectonic plates meet, and one forces another under it. This happens in the Pacific and Indian Oceans. Strain builds over centuries. The tension is unbearable until the megathrust awakens. The Earth shakes with a magnitude that can exceed 9 points, more powerful than any other earthquake. When the seafloor suddenly gets pushed up fast, it sends a huge ripple across the water, and a tsunami of huge force is out. These waves are called teletsunamis, and they cross entire ocean basins, ready to take over coastlines thousands of miles away. The thrust fault stretches over 600 miles. The Earth is not just shaking, it feels like it's tearing apart. This is the power of a megathrust earthquake. Those caught in its path will have to fight for their lives. Japanese authorities recently had to issue their first ever megaquake advisory. It happened because of a strong tremor on the edge of the Nankai Trough ocean floor zone. In the end, most of the warnings were lifted, and there wasn't much damage from the 7.1 magnitude earthquake. Parts of southwestern Japan started to shake, and the superfast trains in Japan slowed down to stay safe, which made travel slower for everyone. But everyone is staying alert as they know about the risk of a megathrust earthquake that could happen within the next few decades in the Nankai Trough. The tectonic plate under the Philippine Sea is slowly sliding underneath the land where Japan is, moving just a few inches every year. The last big earthquakes from this area happened in 1944 and 1946, both with a magnitude of 8.1. These quakes have caused a lot of destruction in the country. The next megathrust earthquake in the region, if it does happen, could be between a magnitude 8 and 9. Scientists still can't agree on how likely this mega earthquake is to happen, but it could be up to 80% certainty. On the other side of the Pacific, scientists from the U.S. Geological Survey have studied a dangerous area along the U.S. West Coast. It's called the Cascadia Subduction Zone, and it stretches from northern California to northern Vancouver Island in Canada. Over the past 14,200 years, there have likely been at least 30 big earthquakes in this region. One major quake happens every 500 years on average. But for a long time now, Cascadia has been quiet, and it worries scientists. They think this might be because the area is locked, meaning the tectonic plates are stuck together and building up a lot of pressure. Eventually, the part of the seafloor could suddenly break and move by several feet. The shaking would be just 5 minutes, but it would create a powerful tsunami as the seafloor shifts that would last for 10 hours. If it happens, it's going to be the worst natural disaster in the country's history, according to experts. The ground on some inland hills could turn into something like quicksand. This would cause the hillsides to slide and crumble, taking down roads and bridges. Around 620,000 buildings could be badly damaged or even collapse, including about 100 hospitals and 2,000 schools. People in Washington state might have to take care of themselves without help for 2 weeks, finding food, water, and shelter on their own. Scientists are studying slow slip events, where the tectonic plates move very slowly over weeks or months, releasing some energy but not enough to stop a big one. Every time the magnitude of an earthquake goes up by just one number, the energy it releases is 40 times bigger. So we'd need about 1 million small earthquakes every day for 500 years straight to release the same energy as one huge magnitude 9 earthquake. But these small earthquakes might be clues that a bigger earthquake is coming. To better monitor the Cascadia Fault, experts are mapping the fault more accurately and adding better monitoring tools offshore. Scientists receive over $10 million to install seismic sensors and seafloor pressure gauges on a fiber optic cable off the coast of Oregon. The goal is to be ready to warn people and potentially save lives when a big earthquake strikes. A sharp megathrust earthquake happened in this part of the world in 1964. It went down in history as the Great Alaska Earthquake and had a magnitude of 9.2. It lasted for more than 4 minutes, making it the most powerful earthquake in the history of the US and North America. The ground shook so hard that it caused huge cracks and landslides. In Anchorage, many houses, buildings, and roads were destroyed because they weren't built to handle such a big earthquake. In some places, the land was permanently changed. For example, the coastline near Kodiak and Hinchinbrook Island was lifted by 30 feet. In other areas, like Gerwood and Portage, the ground sank by 8 feet. They had to rebuild roads higher so they wouldn't be flooded by the tide. A huge 27-foot tsunami wiped out the entire village of Chiniga. Many coastal towns were heavily damaged, not just by the earthquake, but also by tsunamis and the fires that followed. After the main earthquake, there were thousands of smaller aftershocks for months. A moderate earthquake of magnitude 4.4 shook Los Angeles in August 2024. Once it was over, the LA Fire Department checked around the city and didn't find any major damage or anyone hurt. In the nearby city of Pasadena, which is close to the earthquake's epicenter, a water pipe burst inside City Hall and everyone had to leave the building. Thankfully, there was no danger of a tsunami. The best we can do to avoid panic in such situations is to be prepared. Japan is one of the places on Earth where earthquakes happen the most because it sits on the edges of 4 tectonic plates. Around 1,500 of these earthquakes each year are noticeable. Because of this, the people in Japan have learned to live with earthquakes. The 1950 law set a rule that buildings should be able to handle earthquakes up to a magnitude 7 without falling apart. An update 30 years later said that buildings should only have minor damage in such earthquakes and still work as usual. But if an earthquake is even stronger, the law says the building's main job is to not collapse and save people's lives. At the most basic level, buildings are made stronger with thicker beams, pillars, and walls so they can handle shaking better. Another technique is placing special pads made from materials like rubber at the base of a building. Some buildings are even built on thick layers of padding that separate them from the ground completely, which helps protect them during an earthquake. A skyscraper might sway back and forth a lot, moving up to 5 feet. To stop it from getting damaged, engineers can add something called dampers every second floor all the way to the top. These dampers are like giant bicycle pumps, but instead of air, they're filled with liquid. When the building shakes, the dampers push against the liquid inside them. Even though the liquid doesn't squish very much, it can still absorb some of the shaking. When they're building tall skyscrapers, engineers try to make the structure as simple and balanced as possible. This means having each floor the same height and placing the support columns evenly. But sometimes, architects who design skyscrapers don't want to make these compromises because they have creative ideas for how the building should look. Then they have to find compromise solutions. For example, Tokyo's Skytree Tower, one of the tallest buildings in the world, is designed in a futuristic style but also includes special features to protect it from earthquakes. It has a central pillar, like in traditional Japanese pagodas, and seismic dampers that help absorb the energy from an earthquake, keeping the building safe.
Around 3 to 200 million years ago, all the continents were stuck together as one big landmass. Over time, they moved apart and formed the continents we have today. That giant landmass was called Pangaea, and the Earth looked very different back then. Which begs the question, what would our life be like if that split never occurred? Well, let's find out. In simple words, tectonic plates are big chunks of the Earth's outer shell. Our planet is like a puzzle of landmass, and these plates are the pieces. Since the Earth is so incredibly hot inside, its heat influences the rocky ground above the core. Slightly melted rocks start floating in the ocean of scorched magma. This movement creates the tectonic plates, and they're always moving, just really slowly, which is why we don't notice it. Their movement has been a fundamental force shaping the Earth's surface, climate, and the evolution of life over millions of years. For example, when two plates bump into each other, one might go under the other. Or they might slide past each other. Sometimes they pull apart. All these movements create things like earthquakes and volcanoes. And when plates push against each other, it can make the land go up, creating mountains. So, the big mountain ranges on Earth like the Himalayas formed because tectonic plates were pushing into each other. Now, here's the thing with Pangaea. In a supercontinent, all tectonic plates are united, and they don't really move. Well, at least not a lot like they do now. So if Pangaea remained intact for billions of years, everything in our world would look completely different. For example, we wouldn't have many mountain ranges anymore. No Alps, Himalayas, and Andes. What a nightmare that would be for ski lovers. But there's an upside to that too. No continental drift means much less disasters in our world. All our earthquakes, tsunamis, and volcanic eruptions would be much rarer and calmer, or might not occur at all. However, hurricanes would keep existing, and they could be crazy strong. With Pangaea being one huge lump of land, the rest of the world will be water stretching from the west to east. That's just a free water slide for a hurricane. Please feel free to build up in intensity without anything to bump into. So once it finally reaches us, prepare for Category 5 or even stronger hurricanes or tornadoes. They'd be regular visitors too. And if you decided to live in eastern Pangaea, yep, you're doomed. The way the continents are arranged also affects how the oceans move and the weather behaves. In Pangaea, the climate would be very different across the globe. The middle of our supercontinent would be super weird. Right in the center, we'd have a huge dry desert. But there would also be dense, cool rainforests along the borders of this desert. Why? Because Pangaea is so massive and rain from the ocean wouldn't reach far enough inland, so it would be stacking up around the edge. This would make some parts of the land not so great for anything. Rain and water would wear down the land, flattening hills and carrying away soil over a long time. Eventually, Pangaea might even shrink and disappear underwater. Closer to the edges of Pangaea, the weather might be more mild or tropical. Up north, it would be warmer than it is now. And finally, we'd have some understanding of seasons, but we'd have no idea that it becomes harder for you to breathe as you go higher. So, how would all this affect living things? Well, bad. Pangaea would be awful for the variety of life on Earth. History shows that having separate pieces of land is very important for life. It was a big reason why new kinds of species appeared. For example, Madagascar, an island that broke off from Pangaea, was isolated for millions of years, which is why it has many plants and animals not found anywhere else. Fewer isolated lands like Madagascar and Australia mean less cool and unique plants and animals. The climate problem doesn't go away either. Almost all Pangaea would be hot and dry inside, but it wouldn't be all too boring. There would still be some environments for animals to live in. Reptiles like dinosaurs might do well in this kind of climate. That's one reason why dinosaurs thrived when the whole world was one big landmass before mammals came around. Also, this might push for the development of creatures that can live in water. They'd be more diverse and bigger in size. So basically, Pangaea is a master of creating Earth as dangerous for humans as possible. With all this in mind, let's finally see how humanity's doing, assuming that we survived and evolved. First of all, where would your country be located? In theory, you could take a road trip from Brazil to Canada because they'd be part of the same huge landmass. North America would be right here, and Europe would be just east of it. Most of Asia would be up north, and Antarctica would stay down south. Australia would still be in the middle of nowhere. A literal Antarctica would be closer to everyone than Australia. That's assuming that countries stayed the same. And hey, cool news! All our modern countries might not exist at all. Okay, that didn't sound as good as intended. More precisely, the countries would have completely different boundaries, and the world would be much more peaceful and united. Let's see. First, we'd form some tribes. But since we would share the land, we'd have to compromise. We can't all have the only coast or only inland regions. Each tribe would probably get a fair piece of the land so that everyone could meet in the middle to settle problems or make trade agreements. As tribes got bigger, people would move to new lands, separated by deserts and forests, forming their own nations. The hunter-gatherer era might take some more time, since we have fewer animals and plants. If we started hunting, we'd probably wipe out all the big animals pretty quickly. Except for the ones we could potentially domesticate. Imagine having dinosaurs as pets! But the whole supercontinent would quickly enter the agricultural era, because whatever technologies we discover, we'd share them with each other right away. The main difference would be that during our age of exploration, there would be mostly small, isolated islands to discover. Travel and trade would be easier too. Cultures would be less distant from each other compared to our world. For example, right now, Native American culture is very different from Pacific Island culture because they've been separated by water for a long time. But on Pangaea, cultures might form a continuous line from the southern tip to the northern tip, which means all cultures would be very closely related. And that wouldn't be the only similarity. Our appearances would be very much alike as well. Since Earth is still tilted on its axis, the very north and south will stay cooler. So even though some people would still have white skin and blonde hair, in general, everyone would still have less melanin. Around the central part where the sun is always shining, most people will still have dark or tanned skin. This could create a more similar world where people could see themselves as global citizens and Earthlings. The sad part is, we probably wouldn't be as motivated for technological progress as we are now. All the land is already known. There's no need to explore. The weather is mostly good and warm. The crops are growing well. The neighbors are hopefully peaceful, which is why humans would be fine with things as they are. We'd probably stick to basic tools and science. Of course, we're naturally curious creatures, so we'd still have some progress. It just would be very slow compared to our world. What sounds boring for some might sound awesome for us. Our life would be less exciting, but we'd be more united and peaceful. Maybe, in a world like that, we learn to treat each other with more kindness and love. But we can only imagine.
You wake up, gasping for air, struggling to peel yourself from your bed. When you do manage to get your feet on the ground, it feels like they're glued down tight. You're twice as heavy. It feels like you're carrying another you on your shoulders all day long. Well, congratulations. You've woken up on an Earth where uncontrolled experiments with dark matter have doubled the force of gravity. Mass panic happens when over 8,000 aircraft fall as soon as the gravity spikes, crashing into buildings, forests, and oceans. And that's because airplanes suddenly lost the balance between the pull of gravity and the lift force necessary to keep them cruising. Pilots did attempt to save their planes, but GPS failed as satellites swiftly moved. After a month, humans begin to look more and more like chimps. Bones are getting thicker, and the immense force constantly pulling people down is squashing their spines, making everybody bend over. People start figuring out that walking ape-style on all fours helps with better balance and stability. And that becomes a big deal, since even tripping over a tiny rock could lead to a nasty fracture. Falls not only get more intense due to the extra forces on bones and joints, but they also happen faster. Gravity's pull doubles the acceleration force, increasing it from 32 feet per second to 64 feet per second. Your house is not a safe place anymore. Old buildings and bridges all over the world are now collapsing. Inside those still standing, residents get the scary feeling that the whole place is shaking, and cracks start showing up everywhere. It's dangerous to stay inside houses, as roofs are now twice their usual weight, and any rain or snow also feels twice as heavy. Car alarms are constantly going off because tree branches keep falling all over the place. Most trees simply can't bear the weight of gravity, and only strong and small plants survive, like cactuses and succulents. 6 months after the sudden change, supermarkets have a sinister vibe going on, with shelves nearly empty and people arguing over the last loaf of bread. You get frustrated to see that your favorite Japanese restaurant is now 5 times more expensive. And it's not just about salmon prices. It's rice that has become a rare luxury item, since the gravity boost has messed up the photosynthesis process, and the seeds are taking too long to grow. On the flip side, carrots are now cheaper than ever. They're sprouting and growing at lightning speed. People start eating so many carrots that human skin now has an orange glow from all that extra beta-carotene. Farmers are getting creative, using artificial supports to keep plants like tomatoes and corn on their feet. But even with all their efforts, it's hard to get a good harvest. Summer has arrived, and even your air conditioner can't relieve the unbearable heat. A sudden change in gravity disrupted Earth's orbit around the Sun, pushing it into a new, tighter elliptical path. Earth now passes much closer to the Sun than it used to, making your sunscreen simply surrender. The Moon's orbit has also had some dramatic changes, leading to more dangerous and extreme tide patterns. High tides are now higher and low tides are lower. This shift has also triggered widespread volcanic eruptions and earthquakes on an unprecedented scale. Earth's crust starts to rupture across vast areas, unleashing planet-wide lava flows so intense that living on Venus begins to sound like a pretty good idea. 5 years later, people notice that puppies are begging for food twice as much, but they are taking more time to grow. Breeds like beagles look thinner and their leg bones are getting heavier. Even insects, such as locusts, now have thicker hind legs to keep those jumps going. Sea creatures are being crushed by the much greater weight of the water around them. It's not a big deal for animals used to deep ocean pressures, like the anglerfish, but crabs and lobsters are really struggling since they live in shallow waters. Sloths and monkeys develop a stronger grip so they won't fall off trees. For carnivorous animals living in jungles or savannas, life is a real challenge because any animal the size of a wolf or bigger can't run without breaking a leg. Large predators like lionesses are starving because they can't move fast enough to catch their prey. Tall trees like palms and pines also go through evolutionary changes. They get beefier trunks and only grow about half as tall as usual. This way, water and nutrients can travel from the ground up to their leaves without struggling against gravity so badly. 10 years have passed since gravity increased. Airlines have finally made changes to prevent commercial flights from nosediving. The wings of airplanes are now longer. Pilots have learned to fly at altitudes twice as high, and flight speed has increased by 41%. To avoid people getting extremely nauseated and dizzy during takeoffs and landings, seats are now fully horizontal, like first-class bed-like setups, specially designed to minimize the nasty effects of gravity times 2. Flight attendants are trained to raise the seat at the passenger's feet after they pass out, so that blood can return to their head. The thing is, when gravity gets a power boost, it yanks your blood down to your feet and hands even more than usual, making your heart work extra hard to pump that blood around, especially to your head. 50 years have passed. Women in their 30s look like they are 60. Higher gravity decreases collagen synthesis, so even though they're still young, they're dealing with more wrinkles and fine lines, and their skin has already lost a big part of its elasticity. Wounds as small as a pimple pop or a paper cut also take much more time to heal. So people are excited about the creation of a Band-Aid made from fish skin from cod or tilapia that promotes local blood circulation and speeds up the healing process. People have also got used to wear exoskeletons made of titanium, which support and enhance the wearer's strength. This technology features cool joints at the places that copy humans' natural movements, giving people more flexibility and letting them move around more easily. Prototypes of personal flying devices start popping up after 100 years. The Gray Flyer is like a jetpack made of carbon nanotubes, making the structure strong without adding much weight. Instead of using fuel for propulsion, the device has these super thin but high-tech solar panels. Investors are still not sure if humans could fly long distances with it, but the Gray Flyer definitely can help people tackle tasks that have become almost impossible, like climbing a mountain or grabbing something from the attic. Things at the gym are pretty different too. The anti-gravity treadmill is a favorite among fitness enthusiasts because it uses air pressure to lift users, reducing the discomfort of gravity while running. People can also lift weights in booths when the gravity settings are customized. When training with G-force set at 3 or 4 times the new normal, muscles get stronger, making double gravity seem more bearable. However, the maximum set is 4.6, otherwise bones might crack. Over 500 years have passed. Thanks to these amazing technological creations, humans can now handle and establish colonies in other parts of the universe. A popular choice for family vacations is Kepler 452b, a planet about 60% larger than Earth, orbiting in the habitable zone of a sun-like star. Kids especially like that place, as oceans have been discovered and hotels have been built near rocky beaches. On the other hand, traveling to places in the universe with lighter gravity is like going to an oasis of tranquility. So Mars and the Moon have become known for amazing yoga retreats. With their gravitational forces much weaker, people can breathe more easily there and move around with more freedom. Keep in mind that these trips are expensive, so you might want to start saving up now.
Our planet has known terrible floods, powerful tornadoes, destructive hurricanes. Those dangerous natural disasters are familiar to us. Just picture this. Winds howling through the atmosphere at about 500 miles per hour, and they can stick around for weeks. These insane winds have the potential to damage the ozone layer, making our Earth a hostile place for life. It's not some wild Netflix dystopia. These are real-life hypercanes. A hypercane is a hypothetical extreme tropical cyclone the likes of which we've never known. To kick off a cyclone, the sea surface temps have to hit around 122 degrees Fahrenheit, basically hot enough to sear a rare steak. It's tough to imagine, especially since that's nearly 22 degrees hotter than the highest ocean temperature ever recorded. Yep, the hottest ocean water ever was recorded in Kuwait in July 2020. What could cause such a serious increase in temperature? A powerful comet or asteroid impact, an eruption of a supervolcano, or a large underwater eruption. There's even a theory that a series of hypercanes could have sped up the demise of non-avian dinos after the infamous asteroid impact. An important difference between a hypercane and any present-day hurricane is that a hypercane would rise as far as the upper stratosphere. That's up to 25 to 35 miles over the surface of our planet. Meanwhile, present-day hurricanes only go as high as the lower stratosphere, up to 6 miles above Earth. It would make a dramatic, catastrophic difference, but we'll talk more about it later. Hypercanes could gust to 600 miles per hour. For comparison, the most powerful recorded tropical cyclone in terms of maximum sustained winds was Hurricane Patricia. At its peak, it reached a speed of 215 miles per hour. This speed pales in comparison with that of a hypercane. Can you imagine how much destruction such a natural disaster could cause? Should they ever form, hypercanes will also have an enormous lifespan. They could rage for a couple of weeks, if not more. Extremely low pressure inside hypercanes would support massive storm systems the size of North America. At the same time, hypercanes could be as small as 15 miles across. Such relatively tiny formations would lose their strength in no time after wandering into colder waters. On the other hand, the waters after a hypercane could hypothetically remain hot for weeks, hot enough for more hypercanes to form. Since a hypercane would reach far up into the stratosphere, there would be a real chance it could damage Earth's ozone layer. And it would have devastating consequences for life on our planet. The ozone layer absorbs some of the harmful radiation from the sun, preventing it from reaching the planet's surface. Let's just hope to never see a hypercane in our lifetime. Another potential disaster that could seriously harm Earth could be the activity of our very own sun. I mean a massive solar flare. Few natural disasters can wreak as much global havoc. A solar flare wouldn't destroy buildings like a tsunami or earthquake. It wouldn't end lives in the same way an asteroid or a supervolcano would. But if the worst comes to the worst, it would destroy the entire electronic infrastructure of our planet. Recovering from the consequences of this catastrophe would cost trillions of dollars. An incredibly powerful solar flare could cause loads of infrastructures to fail, including communication, medicine, banking systems, and transportation. Earth would be left without electricity for a long time, and people wouldn't be able to reboot the already broken power grids. Water supply systems would be out of order. There would be no food in supermarkets. In 1859, people in different parts of the world woke up in the middle of the night because it was so light outside, they thought it was already morning. The skies were illuminated with colorful auroras. They showed up even in the regions where no one had seen them before, like the Bahamas, Hawaii, or Jamaica. Telegraphs got electrically charged, even though they were disconnected. Fires started in many regions. In other words, the consequences were already catastrophic, even when technology barely existed. Imagine the avalanche of problems a solar flare could trigger today. Then there are gamma-ray bursts. You can't come across this kind of radiation in your everyday life. A gamma-ray burst occurs when two neutron stars collide when a massive star collapses. Gamma rays could turn into a serious danger to our home planet. If a gamma-ray burst happened close to Earth, it would likely rip our ozone layer away. And you already know how crucial this layer is. Plus, gamma rays could create ground ozone. This kind of ozone could seep into the ocean since it's water-soluble, and that would lead to a mass extinction of marine life and plants. According to some theories, if a gamma-ray burst occurred within around 200 light-years away from Earth and its jets were pointed directly at us, our planet would be vaporized. If the distance was greater, but still in the Milky Way, the resulting radiation would sterilize all life on the side of the Earth pointing towards the burst. Another catastrophe that could potentially destroy our planet might be a super eruption, an eruption of a supervolcano. Yellowstone Park is located on top of one of those. The last massive eruption in that region happened about 664,000 years ago. The next eruption might be due anytime soon. Luckily, at the moment, there's no evidence that the supervolcano is waking up or getting ready for an eruption. But if it did happen, a massive column of lava and ash would shoot up into the air to a height of several miles. The volcano would keep pumping ash for days on end. But the most dangerous consequences of the eruption for all living creatures would be ash fallout. Buildings and trees would collapse under the weight of this dense substance. In just a couple of days, a 10-foot layer of ash would cover the territory of 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures would start to drop all over the world. The eruption would most likely be rich in sulfur, an effective sunblocker. So soon it would get so cold that there would be no summer in the entire world for a few following years. It would be hard for animals to find food and clean water. Earth could also encounter a wandering black hole, a region in space where gravity is so powerful that not even light can escape its clutches. At the moment, the nearest to us black hole is around 1,500 light-years away. Seems like there's nothing to worry about. Well, until you find out about wandering black holes. Now things definitely get creepier. If such a black hole entered the solar system, Earth would be doomed. Recently, for the first time ever, astronomers have found a solitary wandering black hole in our home galaxy. This space traveler is 7.1 times as massive as the Sun and is now 5,200 light-years away. Scientists discovered wandering black holes before, but those were in other galaxies. This one is the first to pop up in the Milky Way. Giant sinkholes could also swallow entire communities. For example, when one of such sinkholes opened up in the city of New York in the summer of 2022, it pulled a parked van into the earth. And it wasn't the only sinkhole in that area. Local inhabitants reported around 4,000 sinkholes all over the city between July 2021 and June 2022. This kind of problem is also very common in Florida, and it's much more serious than it may sound. Sinkholes open all of a sudden, pulling down everything and everyone that happens to be nearby. Sinkholes appear all over the world. They're totally unpredictable and form without warning. Luckily, experts know what causes them. In some regions, there are vast areas of groundwater. But during droughts, this water dries up, which creates large, empty caverns. After heavy rains, the surface over such a cavern is likely to collapse, creating a sinkhole within minutes. Suppose everyone in the world wants to do this, and countries started investing billions of dollars in this project. In that case, we can colonize the ocean floor. The question is, why would we need this? For the same reason we're going to colonize Mars, to save Earth from overpopulation. Why do we need to move to the red planet in the near future if we can live underwater? It'll be cheaper, safer, and most importantly, not far from our home. You don't need to stay in cryocapsules for years to wake up hundreds of millions of miles away from your planet. It's much easier to take an elevator down to the underwater city, hang out there, and enjoy the views of marine nature. Besides, staying on Mars will surely cause severe mental problems for people. Panic, stress, and the realization that you can't return to your home whenever you want can put serious pressure on your mind. It's better to live under millions of tons of salt water, and the reason why we have to do this is a need for more resources. There are about 8 billion people on Earth right now. Some experts think that when the number reaches 10 billion, the world will begin to run out of food, fresh water, and fuel. Agriculture and other industries simply won't be able to develop so quickly. Resources will be depleted, and people will have to do something to survive. The colonization of the ocean is an ideal solution to the problem. Firstly, we have very little information about the ocean. We've studied space much better than the ocean on our planet. Most likely, vast reserves of fuel are hidden under the seabed. Secondly, we will be able to reduce the load on our planet by about 50% if we move to live in the ocean. Thirdly, there will be no problems with logistics. Delivering food, necessary equipment, and construction materials will take hours, and if something breaks along the way, you can return to the surface and try to deliver it again. Sending things to Mars would be much more complex and expensive. Imagine that halfway there, millions of miles away from Earth, something breaks down on the spaceship with provisions. Then you'll have to wait for many years for the next delivery. But the main reason for ocean colonization is protection from disasters and natural cataclysms. Volcanic eruptions, radioactive winter, earthquakes, tornadoes, and floods. We could easily wait out any disaster underwater. Yeah, there are volcanoes on the ocean floor too, but the consequences of their eruptions are not so dramatic. The water immediately cools the lava and prevents ash from spreading. We will never experience the consequences of fire again. No burning forests and polluted air. And speaking about the air, there's a lot of oxygen in the ocean. More than half of the oxygen reserves on the planet are replenished by the sea, thanks to algae and phytoplankton. So don't worry, we'll be able to breathe deeply. The main thing is to figure out how to do it underwater. When humanity decides to take such a global step and begins to colonize the ocean, we will first have to adapt our bodies to high pressures. There's such a thing called saturation diving. Before descending into the depths, you must inhale compressed air. The nitrogen and oxygen quickly dissolve in your blood and exert pressure on your body from the inside. At the same time, the water pushes on it from the outside. In simple terms, your body is in balance and you don't feel bad. Divers use this method when exploring the seabed at great depths. Therefore, when people begin to colonize the ocean, they will dive there wearing cylinders with compressed air and an oxygen mask. The main rule is to surface slowly. You need to wait until the compressed air completely dissipates inside your body. If this isn't done and you rise to the surface, then you will feel intense pressure from the inside. Nitrogen will start acting in your veins like soda bubbles when you shake a can with the drink. After this adaptation, we will start building cities, roads, and stations that will transfer people to dry land and back. It shouldn't be too difficult because we already have the technologies needed for the underwater lifestyle. Welcome to the Aquarius Reef Base, located at the bottom of the Florida Keys Marine Reserve. This is a small laboratory where 6 people can live for 10 days. Scientists working there study coral reefs, marine plants, and fish. The lab doesn't look modern. It resembles a sunken, rusty bathyscaphe overgrown with shells and other underwater stuff. To create buildings with more beautiful designs, people will need new technologies for underwater construction. So let's imagine that global colonization has begun. Engineers use durable stainless metals and other materials capable of withstanding high pressure. With the help of freight elevators, people lower everything needed for large-scale construction to the bottom. Stations with such elevators appear in all the seas and oceans. Workers build huge underwater constructions on dry land. Then, large ships deliver them to the stations. From there, they descend to the bottom, where scuba divers and robots set these houses on the ocean floor. Every building is like a giant submarine with lots of apartments. They look ordinary from the inside, except for the underwater view from the window. To reduce waste emissions, engineers build huge capsules in every city, where garbage is destroyed by high water pressure. People try to live closer to the shore because they want to spend less time commuting. This causes severe pollution in coastal areas. Builders set up communication between the stations and land by creating vacuum tunnels with high-speed trains inside. In simple words, this is an underwater subway, only much faster than the one on dry land. From now on, people move farther from the shore to live in cleaner water. Humanity begins to make daily life in underwater cities more comfortable when the main construction is over. Scientists create filters that can quickly purify seawater. Now, everyone has a faucet that takes water directly from the ocean and turns it into fresh water. Also, constructors put in air filters capable of extracting oxygen from the water. Electricians create underwater mills to generate energy. To leave home, a person must put on a diving suit and cylinders with compressed air and exit through an airlock. People swim between buildings and talk to one another using radio communication. For faster movement, car companies produce small bathyscaphes with locked cabins and powerful propeller systems. Over time, engineers create large domes where you can walk and breathe fresh air, like on land. Global clothing brands develop fashionable diving suits and practical accessories for comfortable underwater movement. For example, you can attach a small heater to your clothes to not freeze while swimming. And you can also put on wider fins with engraved brand symbols. To make such a lifestyle as comfortable as possible, scientists and biologists create masks that work like gills and provide a person with oxygen extracted from the water. Constant exposure to high pressure changes people's physiology over time. In the water, we need to put more effort into moving. People who often leave their homes lose a lot of calories. They become slimmer and their muscles get stronger. Look at the Olympic swimming champions. Now, almost all underwater citizens have the same developed shape. Our body temperature is falling, and evolution slowly turns us into cold-blooded creatures. A lack of sunlight makes our skin paler, and we start resembling amphibians. We learn more about deep-sea creatures such as the giant squid and other monsters. Almost every month, scientists discover new species. But at the same time, many fish species disappear because of human activity in the ocean. The extraction of natural resources from under the seabed heavily pollutes the water. To reduce the load on the planet, people decide to colonize the sky. But this is a topic for another video.
At this very moment, scientists are getting ready to explore the Earth's deepest layers, where temperatures are insanely high and the pressure is crushing. It might sound like a plot from Journey to the Center of the Earth, but it's for real. By 2026, the Krafla Magma Testbed project plans to drill into an active volcano in Iceland. Their goal is to search for magma. Yep, that boiling molten rock that we often associate with destruction. It is a high-risk mission and a huge technical challenge, but the payoff can transform our future. This isn't our first attempt to journey to the center of the Earth. Back in 1959, Hawaii witnessed a breathtaking spectacle as red-hot lava violently erupted from 400-foot Kilauea Iki crater. Over the next 5 weeks, lava fountains erupted in 17 major bursts, with the tallest reaching a record 1,900 feet. This spectacular and terrifying event left behind a glowing lava lake in the crater. A few months after the eruption, the lava began cooling and forming crusts. That was a perfect chance for scientists to drill into that lake, see what was going on beneath it, and collect data about the magma reservoir. Over the next 2 decades, they kept coming back, digging a little deeper each time. By 1979, they managed to get 173 feet down. Up to that point, it was the closest we had ever come to an actual magma chamber. And by that, I mean the underground pool where magma sits before eventually rising to the surface and causing a volcanic eruption. Decades later, the dream of reaching magma finally became a reality. We are now in Iceland in the year 2009. The Iceland Deep Drilling Project has just kicked off. Their goal is to transform the Earth's inner heat into clean energy for everyday needs, such as heating homes and supplying hot water for baths. You see, using heat from the Earth's interior to make energy isn't new, but it usually comes from hot water underground, not directly from a freaking scorching magma chamber. That's why the Iceland Deep Drilling Project was such a big deal. Magma could be a clean, renewable power source. And since it's hotter than the geothermal energy we normally use, it could generate a lot more power. Iceland is a natural choice for this kind of project. Known as the land of fire and ice, this country is home to some of the most active volcanoes on the planet. One of the most popular ones is Krafla, a volcanic caldera of about 6 miles in diameter, located north of the island. So, the initial plan of the Iceland Deep Drilling Project was to go there and excavate 13,000 feet deep. But something unexpected happened. When they were only 6,900 feet down, the drill hit magma. Wow! On one hand, it was exciting, because, well, we finally found it. And just like that, Krafla became the first place in the world where we know exactly where magma is. But on the other hand, their equipment wasn't prepared or built for it, and the molten rock basically corroded their infrastructure, bringing the project to an end. Instead of being a failure, this accidental discovery gave us a ton of valuable data. We realized that, with the right equipment, drilling in such extreme heat is definitely possible. Scientists found that these underground molten pools can in fact produce a significant amount of geothermal energy. And most importantly, we learned exactly where the magma was. That brings us to the current Krafla Magma Testbed project. This scientific program aims to create the world's first magma center. The idea is to set up a base where scientists can safely work with magma and have all the necessary infrastructure to run experiments on volcanic risks and geothermal energy. So that's like the basic idea. But their real plan is to return to Krafla, drill back into it, and create a gateway to the magma chamber. The goal is to understand its potential for generating energy, study its properties, and see if we can use it safely and efficiently. If they pull this off, it could provide a nearly endless source of geothermal energy for Iceland's homes and buildings. Even though magma is incredibly hot, reaching over 2,000 degrees Fahrenheit, experts say it is safe to take energy from it and believe the process won't trigger another volcanic eruption in the country. They're so sure about this, partly thanks to the Iceland Deep Drilling Project. But this whole process isn't like drilling for oil or gas. It's way more challenging and risky. Magma is not just extremely hot, it's molten rock, which can wreck equipment and pose serious safety issues. Right now, the Krafla Magma Testbed project is in its early stages. Scientists and engineers are working hard to develop the tech needed to drill into magma safely. They're testing new drilling techniques, creating heat-resistant materials, and running simulations to figure out what happens when you actually drill into a magma chamber. They hope that by 2026 they will be ready for the next step, which means going back to Krafla and drilling all the way down towards the magma chamber. It might take 2 months to reach it. Their plan is to drill a single hole that will go right into the magma body and hopefully keep the equipment running there for many years. If they succeed, scientists also plan to add special sensors down there to measure and monitor pressure. This could help predict eruptions better and prevent disasters, like what happened with Mount St. Helens in the United States. In 1980, this volcano erupted, causing massive destruction and claiming over 50 lives. The eruption was so intense that it completely blacked out sunlight in Spokane, Washington, which is about 250 miles away. While that sounds terrifying, it's nothing compared to a super eruption, like the one that happened over 70,000 years ago at Toba volcano in Indonesia. This disaster was about 1,000 times more powerful than Mount St. Helens. Toba is just one of the 20 supervolcanoes on Earth. A supervolcano is what people call a volcano that can produce an eruption of magnitude 8. These eruptions, known as super eruptions, are the largest and most explosive ones. They could have global consequences by affecting the climate and causing widespread destruction. For example, if Yellowstone had a super eruption today, the surrounding states of Wyoming, Idaho, and Montana would be directly affected. They could be hit by hot avalanches of volcanic ash, gases, and rocks that might reach temperatures of up to 932 degrees Fahrenheit and speeds of over 180 miles per hour. This nightmarish scenario is a real possibility, but predicting when it might happen is almost impossible. Volcanoes don't follow a precise schedule, so it is hard to predict when a supervolcano will erupt next. That is also why the Krafla Magma Testbed is so crucial. By examining a volcano's activity from within, scientists could potentially predict eruptions with much more accuracy. As you might have guessed, drilling into magma is definitely uncharted territory, but the potential benefits are huge. Besides providing a clean energy source and making people who live near volcanoes feel safer, this project might also help us learn more about what is beyond Earth. Yep, it could lead us to breakthroughs in space exploration, helping us understand how other rocky planets and moons formed their crust, just like Jupiter's moon Io, which is the most volcanically active world in our solar system. In the end, the Krafla Magma Testbed project is more than just an experiment. It is a bold vision for the future of energy. It's about pushing the boundaries of science and engineering, taking risks, and dreaming big. So we should definitely keep an eye on Krafla, because this adventure into the fiery depths of our planet could end up changing our future.
So, how long would it take to drain all the water out of the ocean? Any guesses? Well, the water would be rushing out at almost a mile per second. Imagine if we had a drain that was only 2 inches wide. With a drain that size, we'd be able to drain about 105 cubic feet of water every second. But here's where things get mind-blowing. The oceans hold 332,500,000 cubic miles of water. So, if we were to drain it at a rate of 105 cubic feet per second, it would take us, well, get ready to look at the screen. I can't even pronounce this. That many seconds to completely drain the ocean. That's the equivalent of 15 billion years. Never mind where you're going to put all that water you drain. Didn't think about that part, did you?
It was hot in the tropics, a type of heat unknown to the men aboard the Niña, the Pinta, and the Santa Maria ships, led by Italian explorer Christopher Columbus. It had been months since these men left their home cities in Europe, and until then, Europe was all they knew. They were given a difficult and even dangerous task. Spain hired Columbus to find a new western route to Asia.
They needed new routes for trading and buying spices, but it was far from a simple job. I mean, crossing the ocean never is. Little did those sailors know that their lives were about to change forever. "Land in sight!" someone must have shouted on board. But when they finally stepped on that new foreign land, they discovered they were not in Asia. They had landed in the Americas. You've probably heard this tale before. Historically speaking, Columbus arrived in the Americas in 1492. But what would have happened if Columbus's ship had faced a lethal storm in the Atlantic Ocean and had never made it to the new land? What would today's history look like? First things first, nobody discovered anything. When we say that the Americas were discovered, we're kind of ignoring the millions of people who already lived there. You see, the Americas were only discovered from Europe's point of view. Columbus would only have discovered something if when he got there, he was faced with acres and acres of empty land. But that was not the case at all. Second, Columbus was not the first explorer to land in the Americas. Believe it or not, the Vikings approached American shores in the 10th century. Their expeditions have been well documented and accepted by scholars. Here's what might have happened. Around the year 1000 CE, Viking explorer Leif Erikson sailed to a place called Vinland. Cute name, huh? It's now a region in Canada called Newfoundland. But his crew didn't stay too long. They arrived to find 10 Native Americans napping under their overturned canoes. They attempted some trade, but I'm guessing the Vikings weren't too friendly and the Americans didn't really like them. The Vikings' account of the encounter shows they felt outnumbered and menaced, so they sailed away back to their land. That makes sense, right? As I said earlier, there were millions of people living in the ginormous continent of the Americas. Any foreigner would be outnumbered there. Now take a look at what North America looked like before our buddy Chris got there. It was not divided into the normal states we're used to. And if Columbus had never arrived, the United States would probably never have been united to begin with. After all, there were hundreds of first Americans living in these lands, and they lived amongst their own tribes, quite different from the Europeans. It's not accurate to think that there were no political systems going on in the Americas before Europeans arrived. We just need to understand that they were different from what we're used to today. When Europeans arrived, they imported their belief systems with them, from religious beliefs and language systems to things as simple as clothing habits. If the Americas had developed on their own, maybe their sense of fashion would be completely different today. You see, Europeans had a developed sense of fashion by the time they arrived in the West. They wore things such as this and this. But those don't really work in the tropics, do they? For them, fashion had to do with showing a certain economic status, while in the Americas, that didn't exist. For Native Americans, clothing was mainly functional and related to the weather. In warmer climates, Native people would wear short-like cloths to cover their intimate parts. They would walk bare-chested and use shoes known as moccasins. Yes, similar to the moccasins you probably own. In colder climates, they would resort to using leather and fur parkas. Of course, there was always the special clothing used for ceremonial purposes. So I'm guessing that if Columbus never reached the Americas, brands such as the Gap, Hollister, and Forever 21 would have never existed. But we could live with that, couldn't we? Here's a wild thought. Let's say that by the 1700s, Native Americans had developed complex engineering skills. They built big boats, maybe a bit smaller in size than the traditional European ships, and decided to venture across the ocean. Let's say they were the ones who arrived on European shores, in places such as Spain and Portugal. They carried gifts and goods with them for trading, of course. This was also a common practice amongst them back home, known as potlatch. Sure, they were received with suspicion by the Europeans, who had only ever traded with Asia. But with this inverted encounter, a different type of relationship began between Native Americans and Europeans. Since Europeans didn't claim ownership of the Americas, the people from the so-called New Land weren't considered inferior to them. Actually, they stood side by side as equals, each one with their own power and set of knowledge. Native Americans taught Europeans a new type of ruling system, a more decentralized one. So modern-day structures of government would look really different. Maybe Europeans decided that 4 years was a long time for someone to hold decision power, so they implemented smaller and more frequent elections. Oh, and the landscape of European cities also changed a lot. Instead of huge statues made of copper and bronze showing men in ships on their way to the Americas, the Europeans built totem poles in honor of their alliances with first Americans. In terms of medical and medicinal knowledge, they had a lot to exchange about. While Europeans were making advances in traditional medicine, Americans had developed an impressive knowledge of herbs that could heal a series of things. Before they knew it, Europeans were selling different varieties of plants in their pharmaceutical establishments. They had one big barrier though: language. Since Europeans never arrived on American shores, they also never taught their language to Americans. So maybe in this scenario, both cultures brought in their best linguists and tried creating a new language from scratch. Something that could be comprehensible from both perspectives and that could encompass both of their worldviews. The implications of this on modern-day life would be really profound if you stop to think about it. Let's say that this newly created language involved some symbols and drawings in it. You see, Native Americans often told stories using symbols known as pictograms. They were quite literal sometimes. As you can see, a mountain was represented by, well, a mountain. It's crazy to think that this system of communication has been around for 5,000 years, since it was actually invented by the Sumerians. And hey, maybe even our laptop keyboards would come equipped with these symbols, and you could write more visually hybrid and fun emails than the ones you write today. The American landscape would have also changed. You see, if neither Columbus nor any of the other European dudes that went after him reached the so-called New Land, Central and Latin American cities would look completely different than they do today. Maybe the bustling empires of the time, such as the Inca, the Maya, and the Aztec, would have grown immensely. To be fair, they were already pretty big by the time Europeans got there. Some pre-Columbian Maya cities were as big as medieval London and Paris in terms of population. But oh my, the Mayan Empire would have grown so much that it could have spread out all over of Central America. They could have developed their pyramid building craft up to the point that they managed to build an even larger pyramid than the Giza pyramid in Egypt. So tourists would come from all over the world to visit. And in South America, let's just say the region could have turned into a huge forest, bigger than the Amazon. The Inca could have spread through the Andes and then into the mainland. Places such as Brazil and Argentina never existed. But in their place, there would have been dreamy tropical settlements, which would have become a worldwide reference in sustainable living.
Now, we as human beings have faced all sorts of challenges: ice ages, tough diseases, squabbles over real estate, and so on. But let's try to go way back to 400 million years ago, to the times when our oceans were ruled by sea creatures and the lands barely had any animals on them. Do you think you'd be able to survive there? We're talking about the Devonian period. It started around 400 million years ago and lasted really long, about 60 million years. It's named after Devon, England, where scientists first studied rocks from this time. The world was quite different then. Our planet featured 3 continents: a gigantic supercontinent, Gondwana, down south, a smaller one called Siberia up north, and another medium-sized one called Laurasia to the east. These landmasses were moving around and crashing into each other, making big mountains. Now, imagine if your time machine broke down and you ended up in this ancient world. You're now in a world where the land is pretty much a barren wasteland. You are surrounded by basic plants like mosses and ferns. This is the early Devonian period. There were no trees yet, but moss was everywhere. And wow, that's a lot of water! Around 85% of the Earth was covered by oceans during the Devonian, so you see many warm, shallow, oxygen-depleted lakes around you. The first thing you notice is that breathing seems a little harder. Well, don't panic. It's all because of lower oxygen levels, around 19%. It's still enough to ignite fire, and trust me, you'll need one. but prepare to feel a bit dizzy. Luckily, there are no huge predators to run away from, but you'll probably have to do a lot of swimming. Alright, at least the weather seems pretty nice, warm and steady. If you keep traveling, you'll notice that the land seems almost limitless. That's because we're on Gondwana, the biggest supercontinent of them all. Since the tectonic plates don't move around much, there are barely any mountains around, and the Earth actually feels flat. Well, not totally flat. Gondwana boasted a gigantic mountain range, akin to the Himalayas. This range was gradually breaking down, sending sediments into the ocean. Those sediments would provide nutrients that help marine life thrive. In any case, it really feels like a whole different planet. The landscape around you looks like something out of Mars, if it had water. The only question is, where is all the life? Underwater, of course. There's a reason why Devonian is called the Age of Fishes. Now, to be fair, it wasn't all fish. The conditions were perfect for certain early marine life to develop important things, like lungs. Some even gained the ability to crawl out of the water and onto land for short periods. So, if you spot a tiny lizard-like creature around the coast, don't step on it. It's your great-great-great-great-great-grandparent. Well, it's not like you'd be able to really step on it. Remember the guy from the evolution meme with a funny crocodile-like head? His name is Tiktaalik. As you can guess, it was one of the first creatures linking fish to land. And although it might look friendly, it actually has a 9-foot-long body and very sharp teeth. And yes, it can crawl. So if you notice a huge lizard, better find a hiding spot. You'll start seeing more of those Tiktaaliks and four-legged animals in general by the Middle Devonian. But let's risk our lives for a moment and dive underwater. What do we have here? Welcome to Subnautica, Earth Virgin. While the land looks very primitive, marine life is incredibly diverse. We have corals, sponge-like creatures, sea lilies, shellfish that resemble clams, and more. The oceans are filled with various critters that look fascinating and potentially dangerous. Here are some tough armored placoderms, and yes, all of them are bigger than you. These formidable fish had powerful jaws with blade-like plates as teeth. They started as tiny guys who munched on mollusks, but as time went on, some turned into massive fish-slicing monsters, reaching up to 33 feet in length. The biggest of them was Heterosteus with their scary-looking eyes. This other guy, whose name Titanichthys, with its mouth always ready to swallow you. And the largest one, Dunkley Osteus. Oh, those are $5 names, huh? And here are some smaller guys. These are the shark ancestors, the cartilaginous fish. They had small, rough scales, fixed fins, and sharp, replaceable teeth. And finally, there are tiny ancestors of our normal modern sea creatures, bony fish. They're nice and pretty harmless. They were covered in scales and equipped with maneuverable fins. You know what? I think you can cook this one. So the question is, how do you cook it? There are no trees for fuel around, not until the Middle Devonian at least. So you'd have to scrounge up some super dry moss and get to work rubbing rocks together. Fortunately, the warmth of the climate would save you from freezing at night. But since there's not much stuff to burn, you might be better off sticking to a raw diet of mollusks and other early arthropods. In this world of basic plant life on land and a huge ocean around, getting food and resources would be quite tough for you. Perhaps you could stick to fishing or collecting stuff from the sea. Overall, you'd have to be really clever to live off the small amount of plant life and maybe learn a thing or two from the sea creatures about navigating the oceans. In any case, you'd have to start from scratch. Surviving in the Devonian would be quite a challenge. Our bodies aren't built for living underwater or thriving in an environment dominated by early marine life. You need some shelter. Maybe you could try to build a basic house along the shores using dirt and moss, probably. You just need to create tools and shelters using whatever resources you can find. So, get creative. Also, get used to living without clothes, unless you make up a way to create a dress out of moss, seashells, and fish bones, all Little Mermaid style. Alright, to make it more fair for you, Let's say you ended up closer to the late Devonian period. Hey, now things are looking up. At the end of that era, the first forests started covering our Earth. Now we had plants with spores, leaves and roots, and even the first plants with seeds. The land is slowly getting some life. Hooray to normal breathing again! We've got some little bugs, 4- and 6-legged critters. The first land vertebrates, early tetrapods, started showing up. They're pretty cool. Very early ancestors of mammals and eventually us humans. But hold on, Houston, we've got a problem. As plants started taking over the land and breaking the rocks with roots, they released tons of nutrients in the water and caused a chain reaction. The sea got filled with algae, greedy bacteria thrived, and since there was almost no oxygen in the waters, around 70 to 80% of the species vanished. Whoops. But hey, good news for you! Less oxygen-hungry predators in the water. However, now you have to watch out for your new land neighbors. Most of them aren't harmful, but it's better to watch out. But still, with more trees and plants around, you could make useful tools like spears, fishing hooks, and rope. During the end of the Devonian, you might even build yourself a tree house. Picture that, in a world with the first tree ever, reaching 90 feet tall with a super wide trunk. So, it seems like you'd be able to survive without much trouble. You might even turn into a vegetarian with all these plant options. And hey, no more itchy clothes. You could fashion something much more comfortable. And remember that dinosaurs are on their way. Until then, enjoy your time. If people had feathers, wolverine claws, long beaks, sharp teeth, and other features of animals, it wouldn't change our lives globally. We would pay more for manicure services, or wouldn't need knives, using our sharp claws instead. The culture of food consumption would change if we had long beaks. Feather care would create new branches in the field of fashion and self-care. All these things help animals survive in the wild, but they would be pointless for us. But what would change our lives completely would be a drop in our blood temperature. The circulation of cold fluids in our bodies would change our lifestyle and open up opportunities for physiological changes. The coolest thing is that the number of bacteria in our organisms would decrease significantly. Our warm bodies maintain the ideal temperature for both good and bad bacteria. But if we become cold, most microbes won't survive. They won't be able to reproduce, and we will go to the doctor less often. But there's a downside. Those rare microbes that can adapt to low temperatures would cause serious health problems. The fact is that cold blood can slow down your immune system. Protective cells will fight less effectively against unwelcome little guests. Another problem with cold-blooded people, they would depend on external conditions. We warm-blooded creatures can't live at extreme temperatures either, but our organisms can react to any changes and regulate the state of the body. For example, when we're hot, we sweat, and thus cool ourselves. When we feel cold, our muscles tense up, we start shaking, and the blood circulates faster in the vessels to warm us up. These features help to adapt to the cold and heat. But if we were cold-blooded, we'd lose the possibility of this regulation. We would be too sensitive to any temperature changes. Imagine all those reptiles living in home terrariums. Their owners buy expensive lamps to heat their homes. Our houses would look the same. With cold blood inside, we wouldn't become more resistant to the cold. We would become more dependent on warm conditions. We would waste a huge amount of energy on additional heaters and gas stoves. And during cold weather, we would spend all our money on heat. But our financial situation would remain the same because we would spend less money on food. Warm-blooded creatures use a lot of energy to maintain the high temperatures of their bodies, and they take this energy from food. Therefore, cold-blooded people would eat much less, and they would also have a slow metabolism. A hearty breakfast in the morning would be enough to function normally all day. However, not everyone can spend a lot of money on electricity. In cold regions, people would have to keep heaters on almost all year round. It would be much cheaper to move closer to the equator and not waste money on electricity at all. Almost all cold-blooded people would strive to live there. The northern parts of the planet would get empty. But in the southern regions, overpopulation would begin. A considerable number of people wouldn't be able to live comfortably on such small territories. The construction of hundreds of thousands of buildings, millions of cars with exhaust gases, factories, and plants on the equator would significantly worsen the environmental situation. More population density would lead to disaster. But fortunately, the coldness of our bodies would help us with this problem. You know that bears hibernate. These warm-blooded animals put on a lot of fat and then go to their den to sleep through the winter. And at this time, their body feeds on the accumulated fat. However, cold-blooded creatures are also capable of this. And unlike bears, they don't need to stock up on extra calories as they have much lower energy needs. Turtles and frogs can burrow into the silt under lakes and ponds and spend up to 6 months there. The liquid inside their bodies freezes, but the cells remain alive. This allows them to go through difficult times easily. So this ability would ideally help people reduce the load on the planet. Going to the equator is unnecessary if you can spend 6 months of winter in your bed. And people living on the equator could take turns doing it. Have you slept for 6 months? Great, now it's my turn. Of course, this would significantly change the planet's economy. Production capacity would drop. There would be fewer goods and services in the world. There would be fewer taxis in cities and fewer restaurants. But it would reduce the harm caused to the environment. Imagine how easy it would be to wait for the release of some movie or video game. And what would happen to our dreams? Flying in the clouds for 6 months, or speaking with a group of mutant seagulls on another planet would be cool. Lucid dreaming training centers would be opening all over the world so that you could have fun during hibernation. But not all people would agree to such conditions. Imagine training hard, keeping a strict diet, and then just losing 6 months of your life. All your progress would disappear, and you'd have to start from the beginning. Interestingly, there would be fewer athletes in such a world. Another superpower of cold-blooded people would be the ability to live underwater. Dolphins, whales, seals, and other mammals live in seas and oceans. But for some reason, evolution hasn't given them gills. They can't extract oxygen from the water like fish, so they have to swim to the surface many times per day. The reason for this is their warm-bloodedness. Cold-blooded fish don't need a lot of oxygen. They extract a small part of it from the water with the help of gills, and it's enough for them. But this wouldn't be enough for warm-blooded creatures. If dolphins had gills, they would be huge, since dolphins need 15 times more oxygen per pound of their mass than cold-blooded fish. Gills need to constantly move large amounts of water to extract oxygen. Sharks must always be in motion to get the necessary supply. Now, if humans had gills, they would be gigantic, and we would have to swim very fast to get enough oxygen. But everything would be much easier if people were cold-blooded. Perhaps if we started living in the water, then evolution would give us gills in a couple of thousand years. We would have a better chance of regenerating with a low body temperature. Cold-blooded starfish, lizards, and salamanders can grow limbs and organs and even completely restore their entire body systems. With such a superpower, we would be able to defeat aging, save millions on doctor's visits, and avoid surgeries. But would we be able to fly if cold blood flowed in our veins? Unfortunately, we wouldn't be able to grow wings. A bird is a warm-blooded creature with a fast metabolism. It needs a lot of oxygen and energy to fly. If people in some parallel universe could fly, their bones would be much lighter and more fragile, and their muscles would be more developed. Even with these anatomical changes, they wouldn't be able to fly freely like pigeons or sparrows. Flying people would be clumsy and barely maneuverable in the air. They would need to learn how to absorb more oxygen in flight. Otherwise, they would fly with oxygen tanks. Or probably evolution would make their lungs much bigger. Despite many pros, cold blood is still a disadvantage. Perhaps our brain wouldn't be as developed since it would need less energy. So it's good that our blood is warm. We don't have gills, but we cross oceans on ships. We don't regenerate fast, but we have advanced medicine. We have a fast metabolism, and there's a lot of delicious food in the supermarket. We now have the ideal body structure for a comfortable existence in this world. But how would our life change if our body temperature rose 2 times? Well, that's a story for another video. Hey, watch this space. Hurricanes can be a lot scarier than we often realize, especially since they can actually trigger earthquakes. This surprising and frightening phenomenon, known as stormquakes, was discovered completely by accident not too long ago. It started with scientists trying to find out more about low-frequency earthquakes. We're talking about those earthquakes that are so weak that we can't actually feel the tremor. See, beneath our feet, the Earth is constantly vibrating in subtle, unceasing ways that we can't hear or see without the right equipment. This geologic hum, so to speak, is driven by the movement of oceans, which covers about 70% of our planet's surface. Scientists have found that this hum may actually provide useful records of environmental happenings. To figure out where it's coming from, experts used equipment known as seismometers. You can think of these devices as little ears pressed to the ground. They can pick up all sorts of vibrations, like fans jumping up and down at their idol's concert, airplanes flying by, or even super distant earthquakes shaking the ground. Very low-frequency earthquakes are hard to track over long distances because the signals they produce can look different on different measuring devices. To solve this problem, experts came up with a way to track these signals by combining readings from smaller areas, kind of like putting together a puzzle. But while doing this, they stumbled upon a strange set of events that looked a bit like the earthquakes they were studying, but were not exactly the same. The first weird thing they noticed was that this specific phenomenon was seasonal. It never happened between May and August, for example. That is completely different from earthquakes, which can pretty much happen any time of the year. The second strange thing is that earthquakes usually occur more in the western part of the United States, where the ground moves along cracks in the surface. But these new strange vibrations spread not just along the west coast of North America, but also over to the east side. So what could be triggering this new phenomenon? What they surprisingly discovered is that many of these tremors coincided with the same time that massive storms hit North America. So we are essentially talking about a chain reaction. What happens is that during a specific season, hurricanes or heavy storms can transfer energy into the oceans, creating very strong waves. These waves then interact with the solid Earth, producing intense seismic activity. These bursts of energy that are born from massive storms can radiate thousands of miles across continents, leading to what we now call stormquakes. It is believed that this phenomenon can trigger earthquakes at a magnitude of up to 3.5 on the Richter scale. This means it can be felt by many people, but normally doesn't cause any damage. But that doesn't mean we can all be relaxed now, as ocean waters can indeed increase the intensity of hurricanes. Just like what happened with the frightening Hurricane Milton, which recently left a path of destruction across Florida. The blue-purplish zone you're looking at is Hurricane Milton, seen from a satellite perspective. On October 9th, this hurricane sustained winds of 155 miles per hour and lashed the region with heavy rainfall, damaging winds, and life-threatening storm surges. Estimates show that the losses could be up to $34 billion, which could make it one of the costliest storms in United States history. What happened with Hurricane Milton was pretty tricky. It all started with some record hot water in the Gulf of Mexico. That warm water acted like a power-up, giving this hurricane the energy it needed to grow. And then, there was also this process called eye wall replacement that helped it get bigger too. We'll get to that in a moment. So as Hurricane Milton approached the coast, something unusual happened. It crossed paths with a fast-moving air current called the jet stream, which flows high up in the atmosphere. Now normally, the winds in the northern and northwest parts of a hurricane are not as strong as those in other areas. But because of this interaction with the jet stream, the winds in these parts of the storm became much stronger than expected. At nearly every turn, Hurricane Milton surprised everyone and intensified faster than we have seen in ages. It threatened to slam both Florida's west and east coasts with a dangerous surge of water. putting the bustling area of Tampa Bay, which is home to over 3 million people, at serious risk. So how did Milton become such a major problem? Well, the problem started in the eastern Pacific Ocean. Usually, hurricanes follow a fairly predictable path, spinning off of Africa's coast, sailing across the Atlantic, and gaining strength in the warm Caribbean waters. But Milton had a twist in its origin story. It began as the remnants of a tropical depression that crossed over the Yucatan Peninsula and met a stalled front in the Gulf. Once Milton got going, it didn't hold back. But when it hit those record-high ocean temperatures, it was like giving it an energy drink. The warm water and humid air were the perfect ingredients for a hurricane on the rise. Quickly, Milton's wind speeds increased by 92 miles per hour. So it went from a tropical storm to a Category 5 hurricane in less than 2 days, which is basically insane and off the charts. And if that wasn't enough, Hurricane Milton also went through this thing called eye wall replacement. Now, hurricanes spin around a mostly clear eye in the center. But overnight, Milton started forming new bands of rain on its outer edges, creating a second ring around its eye. This process helped Milton grow even bigger, spreading out the wind speeds and giving it a larger footprint. It's kind of like shedding its skin and getting ready to become even more powerful. Hurricane Milton also had this little wobble in its path, which changed where it was heading. You can think of it like a spinning top that gets nudged and wobbles a bit before finding its balance again. That wobble meant some areas could get either hit hard or be spared from the worst of the storm. Thankfully, Hurricane Milton weakened a bit because of some tricky wind changes up in the atmosphere until it finally made landfall. After that, it moved across the peninsula and headed out to sea, quickly losing strength as it pulled away from the warmer waters. Now, even though the damage was significant, the good news, if you can call it that, is that experts were honestly expecting things to be way worse. Still, it raises a question. How close was Milton's wind speed to the maximum? Or, in other words, is there a limit to how strong a hurricane can get? Well, the answer is yes, there is a speed limit for hurricane winds, but it's not a set number. Right now, the strongest the storm can get is around 200 miles per hour. But that maximum speed can change depending on many factors, like the heat in the ocean. Think of the ocean as the fuel for hurricanes. The warmer the water, the more fuel these storms have to work with. Experts believe that as the oceans continue to warm, they can ramp up the wind speeds and the impacts of hurricanes, making them a lot stronger. But other things can also help figure out how intense a hurricane can get. For example, the heat in the air and the temperature at the top of the clouds matter, as they also affect how fast heat moves from the ocean surface to the top of the storm. Some estimates suggest that maximum wind speeds could reach closer to 220 miles per hour until the end of the century. So it's definitely something that experts need to keep an eye on to help prevent future disasters. As we move forward, it's essential to keep researching and studying these storms. The more we understand them, the better we can protect ourselves and our communities.
Look at this ominous dark cloud. Is it rotating? What on earth is happening here? What you see is called a supercell. It's a storm, often a thunderstorm, that contains an updraft rotating about a vertical axis. That's why they're also called rotating thunderstorms. There are actually 4 types of thunderstorms: single cell, multicell, squall line, and supercell. Out of them all, supercells are the rarest and the most severe. They're typically isolated from other thunderstorms and last for 2 to 4 hours. Supercells are very common for the Great Plains of the United States, in particular, the area known as Tornado Alley. But they can occur in other parts of the world too. For example, in Europe, Argentina, Uruguay, and southern Brazil. These storms can be any size, large and small, high or low-topped. Supercells are also associated with the most severe tornadoes, even though not every supercell can create one. These storms usually produce great amounts of torrential rainfall and hail, and are accompanied by powerful winds and downbursts. Downbursts are powerful winds that come down from a thunderstorm. Once they hit the ground, they spread out very quickly. These winds are dangerous since they can cause a lot of damage. Even though they're often confused with tornadoes, downbursts are a totally different phenomenon. Let's have a look at how a downburst forms. At the beginning of a thunderstorm, there's a powerful updraft. That's why the cloud grows vertically, and hailstones and raindrops start forming inside. The storm matures, and the updraft keeps feeding the cloud with unstable, moist air. Hailstones and raindrops are now big and heavy enough to fall to the ground. But sometimes, the updraft is so strong that it suspends huge amounts of hail and rain in the upper part and the center of the storm. But let's say some dry air gets into the middle and lower parts of the storm. It can cause a downburst. When it happens, all that amount of rain and hail from the upper part of the storm dashes toward the ground, dragging along a lot of air. All this mass gains speed, and when the downburst eventually reaches the ground, it's like a stream of water coming out of a faucet and hitting the sink. It spreads in all directions at an incredible speed, sometimes more than 100 miles per hour. But what you might most likely come across is called a microburst. It means that those terrible winds are confined to an area smaller than 2.5 miles across. While speaking about tornadoes, I can't but mention volcanic tornadoes. They're possibly one of the scariest natural phenomena. When a volcano erupts, it throws hot rock and ash high into the atmosphere. As for lava pieces and hot gases, they travel down the volcano's slope. When this flow is moving down, some of the gases trapped inside begin to rise and spin at the same time. They get squeezed by the surrounding air, which makes them spin faster and faster. That's how a volcanic tornado gets born. On the bright side, this phenomenon has a very short lifespan. If you ever see a tight burning column of air, that's a fire tornado, a creepy combination of whirlwind sounds and scorching inferno. This phenomenon is also called a fire twister or fire whirl. This dangerous natural phenomenon mostly occurs during wildfires. While burning, such fires create a big area of boiling hot air just above the ground. And when this scorching air gets mixed with the cooler air higher up, it results in a whirlwind that churns up burning debris and flames. The most powerful firenados can stretch hundreds of feet into the sky. Another dangerous natural phenomenon is called a snow squall. If you get caught in a snow squall while driving, you won't find a safe place on a highway, because this is an intense, but thankfully pretty short, period of heavy snowfall that comes along with powerful gusty winds, and sometimes even lightning. People have known about this phenomenon for quite some time, but the term itself, as well as the warning associated with this danger, appeared only in 2018. Another danger of snow squalls is something called a flash freeze. Come to think of it, it makes sense. Rapidly dropping temperatures and freshly fallen snow glaze highways very fast. This makes controlling your car almost impossible. The next curious phenomenon I'm going to talk about happens extremely rarely and is still poorly understood. It's usually not something big and turbulent. Dust devils can be tiny and vanish within minutes. They've got lots of names: whirlwinds, dusters, and sand spouts. Dust devils look like funnels of sand spiraling upward from the ground. But unlike their terrifying relatives, tornadoes, these babies are normally nothing to worry about. And still, according to the definition, dust devils fall in the same category as hurricanes and tornadoes. All three natural phenomena feature a column of air kind of spinning around an invisible pole. They're all formed during the collision of different types of air: moist versus dry, or hot versus cold, and so on. But hurricanes usually form over a body of water where cold air slides under warm air. Tornadoes spiral down from the sky when hot air rises through a mass of cold air, and dust devils form on the ground. Even though we call them dust devils, they can actually swirl any loose debris. The main criteria: the pieces have to be small and light enough to be lifted by a fast-moving vortex. By the way, Do you know that some clouds can predict extreme weather? For example, shelf clouds. They look like something from a sci-fi movie. They form when warm and moist air gets caught in a thunderstorm updraft. These ominous clouds most often mean a storm is coming. Those huge white lumps over your head are called mammatus clouds. They can make you believe the sky is falling. Most clouds form when air rises into the atmosphere, but mammatus clouds appear when moist and cool air goes down and mixes with dry air. The result is these unique puffed rice clouds. By the way, if you see this phenomenon in the sky, bad weather is just around the corner. Morning glory clouds are extremely rare and harmless. They look like massive tubes stretching across the sky. They can snake for more than 600 miles, sitting relatively low. Most researchers agree that these clouds appear when an updraft squeezes through the cloud. This creates the signature rolling appearance. The cool air at the back of the cloud makes it sink downward. The best, but not the only, place to see the morning glory is Australia's Gulf of Carpentaria. If you decide to travel there to see these clouds, choose a period from late September to early November. Ever seen huge round discs in the sky? Most likely, those were lenticular clouds. They usually form over large and high places, like mountains or hills. When strong wind bumps into some barrier, this creates an air wave. The air kind of wraps around the obstacle, and the higher the barrier is, the colder the air that is rising over it becomes. At some point, the moisture it contains turns into water droplets, and they form these unusual clouds. Lenticular clouds can look like waves, a pizza, or even a stack of pancakes. And these clouds, on the contrary, form low in the sky and after some bad weather. Rainbow clouds appear on top of puffy low-altitude clouds after thunderstorms. They usually hover at the height of around 6,000 feet. When the water vapor they contain condenses, the resulting droplets act like prisms. This forms multicolored caps over the clouds. And a pretty scary bonus fact for you. One of the most common causes of wildfires is lightning from thunderstorms. But have you ever heard of a wildfire that triggered a thunderstorm? Well, now you know. It happened on May 11, 2018, not far from Amarillo, Texas. Then, the super powerful Mallard Fire not only created a massive dense cloud high in the air, but its heat also caused a violent thunderstorm that later dumped tons of quarter-sized hailstones 60 miles away in Wheeler County, Texas.
Nature can ruin your life with a tsunami, hurricane, tornado, rainstorm, and many other destructive events. But did you know that it also has other, weirder ways to destroy? Let's take a look at the most unusual natural phenomena. How about the orange rain? It's not that orange drops are falling on you. No, the whole sky and the atmosphere are turning dark orange. Orange clouds are pouring dirty orange drops on you. Don't worry, they're not poisonous, but watch your eyes. Don't let the drops get in because they contain sand particles. If you want to see this unusual phenomenon, go to the Canary Islands. Every year, the sky turns orange there and pours orange-red drops of water mixed with sand onto the ground. This phenomenon happens because of the Sahara. In the desert, strong winds blow millions of tons of dust and sand into the air. All this mess penetrates the atmosphere and turns the sky orange. Then, the particles from the Sahara fly toward the Canary Islands and fall on people in the form of heavy rain. Residents of this region experience breathing problems and poor vision in the orange conditions. Airports stop working. All flights are canceled. Under favorable conditions, a storm that carries sand particles can reach both the Mediterranean and Northern Europe. Therefore, if you suddenly see red rain, don't be scared. This is not the apocalypse. Warning, this kind of rain causes anxiety. During this phenomenon, you won't see drops of water. There will be spiders falling from the sky. People have faced spider rains in Australia, the United States, and the United Kingdom. These creatures are called money spiders, or sheet web weavers. During strong winds, they climb as high as possible to the tops of plants, bushes, and fences. Then, they release a parachute-shaped web, and the wind blows them into the sky. They fly high into the air, meeting birds, cold winds, and harsh weather. Not everyone can survive this journey. Then, when the weather calms down, this tiny party lands on the ground. No one knows why spiders behave this way. According to one version, they fly away from places where flooding can begin. In other words, it's a forced migration. And because of this migration, spiders often become the first settlers of territories that have been destroyed by fires or other natural phenomena. But don't worry, these creatures are harmless to humans. They just want to live and multiply. Although, to be honest, it's hard to stay calm when thousands of arthropods are falling on your head. Tornadoes are a destructive force. But look at this. A whirlwind appears during a snowstorm. It's sucking in more and more snow. Now, it's not just a tornado, but a snow-nado. It looks like something terrible and destructive, but don't worry, it's not as scary as it seems. This is a fairly rare disaster that has recently occurred in Utah. The snow tornado came across a man and his dog on its way. It looked impressive and dangerous. Fortunately, no one got hurt. This phenomenon occurs when an air vortex raises snow from the ground. If you see a similar vortex next to you, don't panic. Usually, such phenomena are harmless and don't have enough force to destroy things. This natural phenomenon is much more dangerous than the snow-nado. Just imagine that a mountain of chunks of ice is moving along roads, sweeping away everything in its path. It looks like a tsunami, but instead of water, there are ice boulders. The ice tsunami can destroy houses, cars, and trees. It can move on grass, asphalt, and sand. It can jump out of the water like a crazy salmon. Fortunately, the ice tsunami is not a frequent phenomenon. It occurs when three conditions are met: a flat coast, loose ice, and strong wind. Waves and wind are throwing broken pieces of ice onto the shore. These ice flows accumulate into a huge wall, and then, during strong winds, this ice monster begins to move. Therefore, if you see a large pile of ice near the water, move away from this place as far as possible. And we're back to the tornado again. You already know about snow tornadoes. You've probably seen the footage of tornadoes in a desert when the wind blows sand into the air in documentaries. Tornadoes pass over the ocean's surface and can create a funnel inside the water. But there's a phenomenon that's even cooler and more impressive. It's a fire tornado. Surely not many of you have heard about this thing. It's a very dangerous phenomenon, but people have ventured close to the fiery tornado to study it. But firefighters, by the way, often encounter this devastating phenomenon. A fire tornado forms during forest fires, and sometimes it can appear inside a burning building. If you see a big flame and feel a strong wind, be careful. A fiery funnel may form. But how does this happen? Let's first look at the origin of an ordinary tornado. So, we're somewhere in a dry place in the middle of a hot day. The sun heats the air that is close to the ground. Its lower layers absorb more energy than the upper ones. An increase in temperature makes this air less dense and more buoyant. Then it lifts into the sky in the form of long columns. This rise has a spiral movement. The water in your bathtub moves similarly when it flows through the drain hole. So many of these air vortices are quite weak, and you can't see them. But some of them encounter strong air currents. This accelerates their movement, adds energy, and increases the area. More and more air gets into this vortex, making it stronger. When dust and sand get into these whirlwinds, you see a tornado. The fire tornado follows the same pattern, with only one difference. The air below is heated, not by the sun, but by fire. Fire heats the air, it rises, rotates, and pulls the fire inside. Some of the vortices can reach up to 400 feet high and 50 feet wide. It's like a thin, leaning tower of Pisa, made of fire, only twice as tall. This is a truly devastating and terrifying phenomenon. The ground is shaking. Flocks of birds are flying away. you can hear a loud, low rumble. The volcano spits out a giant ash cloud. Lava is flowing from the mouth of the fiery mountain. Rivers of fire are running down and dashing towards you. You have nowhere to escape. The fire is getting closer and closer and… Wait a minute. This lava isn't hot. It's cold. How is that possible? You can observe cold lava flows near many volcanoes. In Indonesia, for example, this phenomenon has recently destroyed entire villages. Yes, it's not hot, but it's still dangerous. Cold lava streams occur when hot lava mixes with ash, sand, and pebbles during wet weather. In a sense, the volcano spews out streams of heavy mud. It covers roads, houses, cars, and trees. Cold lava flows are a destructive phenomenon, so stay away from them. Even if some volcano is very beautiful and you want to take cool photos, don't take any chances. Okay, let's relax a little and end our video with something fun. How about surfing? But instead of ordinary waves, we have icy ones. This phenomenon is called the ice wave. It looks as if someone paused a wave while it was forming before it hit the water. It's a rare occurrence, but you can find it on Mount Washington. The top of the mountain is shrouded in fog most of the year. Cold temperatures, humidity, and winds form frost. Then strong winds force this frost sideways, and thus a wavy shape forms. And when there's a wave, you can ski or snowboard inside, like a surfboard. But be careful, it's pretty cold in there, so wear warm clothes.
Something interesting has recently happened in South Dakota. It was all over the internet, so perhaps you already know about it. In July of 2022, the sky in this state suddenly turned green. So, what happened there? Was it caused by a human or by nature? Let's find out. Tuesday, July 5th, 2022. Shortly after a heavy storm, the sky over South Dakota in the US was still overcast. Locals finally went outside and saw that the sky had an intense dark green hue, and they'd never seen anything like that before. People said that it looked like something straight up from science fiction, or even a horror movie. Unsurprisingly, South Dakotans immediately started spreading the news all over social media. People shared their beautiful, yet very eerie pictures on Twitter. They showed the sky over the city of Sioux Falls and a few other towns. Even though it may look like something supernatural, in reality, this is not a terrifying phenomenon at all. It's a simple play of the light and the atmosphere. Something like this happens quite rarely, and usually means that really bad weather is approaching. And that's also true to what happened in South Dakota. Just before people started sharing photos, a thunderstorm swept through the town of Sioux Falls. This was confirmed by the U.S. Weather Service. This hurricane was terrible. The wind speed was about 100 miles per hour. According to the Beaufort scale on wind speeds, this is the fastest and most destructive storm. There are only 12 numbers on this scale, and the maximum wind strength starts at 73 miles per hour. But why isn't this all over the news then? Well, because it's kind of a usual thing for the residents. Thunderstorms occur very often in the United States, especially in the warmer months. And 1 out of 10 such thunderstorms can become something serious, like a tornado. This one wasn't an exception. It was the so-called derecho storm. Derecho is very widespread and long-lived. It's actually a combination of a fast-moving group of severe thunderstorms and downpours. People often say that a derecho is as strong as a tornado. Still, there's a difference between them. A tornado is a vortex, a rotating column of air. It's usually about 500 feet in diameter, although sometimes its width can reach up to 2.5 miles. I don't envy those who would stumble upon that. But the main point is that they rotate. The wind moves very fast in a circle, near some invisible center. A derecho is a strong thunderstorm, or a system of strong thunderstorms with straight-line winds. In other words, it doesn't spin. Instead, the derecho chooses a point somewhere and simply runs to it. like a very motivated marathon runner. If we compare a derecho to an ordinary tornado, the latter has 6 levels of strength, from 40 to 380 miles per hour. So a derecho is kind of like a small, average level 1 to 2 tornado. Usually its speed is within the range of 73 to 113 miles per hour. And in both cases, they can be accompanied by severe thunderstorms, lightning, and rain. But still, these are different things. A storm becomes a derecho if the damage trail left by it exceeds 240 miles, and if the wind speed is at least 58 miles per hour. It's quite difficult to predict. It can form even on a clear day when meteorologists don't even anticipate any storms. And then, the winds appear suddenly. It's so surprising that they may even feel explosive. But the National Weather Service tries to warn people at least half an hour or an hour before this happens, so that residents have time to prepare and hide. It wasn't any different this time. The storm swept through almost all of South Dakota, as well as the states of Minnesota and Iowa. The consequences were quite serious. More than 30,000 people were left without electricity. Fortunately, people were fine. That's because the locals are pretty used to derechos. However, the green sky is something different. It became a very unusual sight for the locals. Everyone was wondering why it happened. Was it a bad sign or a normal weather phenomenon? Well, to be honest, scientists don't have an exact explanation. But although there are only assumptions, they sound pretty convincing. A green sky is a very rare phenomenon. Most scientists think that this happens when a powerful storm approaches the area before sunset or sunrise. Then the sky will turn green in this area. NBC meteorologist Bill Cairns, who once faced a similar event himself, suggests that the green sky appeared because of the huge hail before the storm. First, let's talk about why the sky looks blue, or any other shade, depending on its mood. In short, the sun simultaneously carries all the rays of the color spectrum. It may seem white to us in total, but it actually has all the colors at the same time. However, these color waves all have different lengths. For example, blue rays are shorter than the other ones. They jump away from the air molecules better than the red waves, so they reach us faster. Because of this, on a regular clear day, the sky seems blue. At the same time, red and orange color waves are very long and move slower, so they're usually left behind. But when the sun goes below the horizon or rises, the rays' directions change, and these waves reach us better. It all means that even if the sunrises and sunsets seem red and orange to us, in fact, there are still blue and green waves among them. But they have to bounce off something to reach us faster and become stronger than the red rays. Have you guessed what I'm getting at? This is where the water comes into play. Clouds are made up of water droplets. When they become large enough, but don't fall yet, for example, due to strong winds, they affect how the light behaves in the sky. Large, heavy storms mostly consist of water and hail, and water reflects blue and green rays best of all. That's exactly the reason why the water in rivers and lakes seems bluish-green to us, although in reality, it's transparent. And yeah, algae matter too. So, there are a couple of key factors why the sky may turn green. First off, the sun should be at the horizon level. Another factor is that while the storm clouds are approaching, they shouldn't cover the sky completely. There still must be a little room for the sun rays. Then, barely noticeable blue rays jump up to storm clouds. They're repelled by water droplets and hail. Mixing with the red sunset, they turn into a bright green light. And this green light is spreading all over the sky. That's why in most of these cases, when the sky turns green, people can only see it in the evenings. Yeah, it can also happen in the middle of the day. But since the conditions are already quite specific, seeing something like that during the day is even rarer. Still, if you see a green sky, you don't need to panic. It doesn't necessarily mean that a terrible storm is approaching. The chances are high though, but still, it's not a rule. It can be just heavy rain or a heavy hail. In other words, if you see a green sky, then you'd better hide, and hide your car. However, if you were lucky enough to see the stunning sky from the comfort of your own home, it's indeed very exciting. If you get a glimpse of something like that, just know that you had a chance to experience something very rare and special. Some people said it was the most incredible thing they had ever seen.
It's normal for planets to be a bit tilted on the side. The Earth is tilted at a 23-degree angle. That's why we have seasons. It's summer when the part of the world where you are leans closer to the sun. It works the opposite way too. It's winter when you lean away from it. But Uranus is tilted more than normal. It lies as a 98-degree angle, which has a huge effect on its seasons. Each season on Uranus takes 21 years to play out. Something to think about the next time we complain that winter lasts forever. Now, here on Earth, we measure distances in minutes and hours, maybe even days. It takes 10 minutes to walk to your best friend's house, or 15 minutes to drive to your favorite cafe. But in space, it's different. It's vast, which means we measure how long it takes to get to a certain point in years, or in most cases, light years. So, if you want to walk to the moon one day, that would take you 9 years to span the 239,000 miles. Perhaps you'd like to take a ride to the nearby star, Proxima Centauri. Maybe if you kept the pedal to the metal at a constant speed of 70 miles per hour, you'd get there in about 356 billion hours, or around 40.5 million years. Trust me, after the first 20 million years, you'd be second-guessing yourself as to why go there in the first place. Now, Mars contains the biggest valley, Valles Marineris, we've discovered so far. It's a pretty impressive system of canyons, 2,500 miles long. That's 5 times longer than the Grand Canyon. Researchers first spotted it back in the 1970s. A bank of volcanoes located on the other side of the canyon ridge probably helped form this valley. We haven't discovered a planet completely made of diamonds yet, but on some planets, it actually rains diamonds. On Jupiter and Saturn, gas giants of our solar system, lightning storms turn abundant methane into soot, which we also know as carbon. The soot falls and transforms into graphite. Further graphite transforms into diamonds with a diameter of about 0.4 inches. Now, before you start figuring out how to book a diamond collecting field trip, know that these diamonds don't last. After they enter the planet's core, they melt. Ever notice how when you're stargazing 2 nights in a row in the same time, let's say 9 p.m., the stars stay in the same place, but the moon doesn't? Well, there are 2 reasons for that. First, it depends on what time you go stargazing. For instance, if you go outside at 8 p.m. and tomorrow you look for it at 11 p.m., you'll see the moon in 2 pretty different places. In this case, even the stars take different places in the sky since our planet is spinning. As you know, it takes 24 hours for it to make one full circle. That means, from our point of view, it seems like both the sky and everything up there is just moving around us one time per 24 hours. In the same way, the sun changes its position, rising and setting every day. So, if you went outside 2 nights in a row at the same hour, in most cases, you'll have to wait for an extra half hour or more until the moon gets back to the same position as the night before. The stars are pretty much standing still. It seems like they're moving, but that's because the Earth is spinning. But the moon is actually moving around our planet and goes through different phases. For example, a new moon is when it's completely dark in the sky. A full moon is when its day side is facing the Earth. It takes approximately a month for it to finish one circle around the Earth. Maybe you'd be luckier on a diamond collecting expedition on this next planet, 40 million light-years away from Earth. Scientists used to call it a super-Earth. Now, a super-Earth is generally a planet way bigger than ours. This planet, for example, is double the Earth's size. It's so close to its star that it makes a full circle around it in less than 18 hours, which means a year there is pretty short. Since it's so close to its star, its temperature goes up a whopping 4,900 degrees Fahrenheit. Because of the heat, in combination with the planet's density, Scientists have the theory that its core is made of carbon in the form of graphite and diamonds. Over 10 years ago, astronomers discovered a huge water vapor cloud. It was 12 billion light-years from our home planet. That cloud is the biggest source of water we know of. It's also the oldest, dating back to when the universe was only 1.6 billion years old. Now it's 13.8 billion years old. Man, if only I had started a savings account 12 billion years ago. With compound interest, I'd have me quite a pile of cash by now, but I wasn't around then. Anyway, this cloud is so large it holds 140 trillion times the amount of water in all the oceans on our planet. This cloud kind of feeds a black hole. It may also contain enough gases, such as carbon monoxide, to encourage the black hole to grow 6 times bigger than it is at the moment. The average temperature of our planet is about 57 degrees Fahrenheit, and the highest temperature ever measured was 134 degrees. Sound too hot? Well, on Venus, it can go up to 900 degrees, which makes it the hottest planet in our solar system. It's not hot enough to melt steel, though. It would need to be higher by 2,500 degrees to get there. But it's hot enough to melt lead, and it's way too hot to sustain life, at least not in any form that we know. Venus is not even the closest to the Sun, it's Mercury. But it has a super thick atmosphere that traps greenhouse gases. It's like you covering yourself with a pretty thick blanket in the middle of the summer. Now, we're used to seeing volcanoes spewing hot molten lava. After all, that's what they mostly do on Earth. But in space, volcanoes tend to spew methane, water, or ammonia. And these materials freeze as they erupt and eventually transform into frozen vapor and something called volcanic snow. I'm talking about cryovolcanoes here. You can find them on Jupiter's moons Io and Europa, Saturn's moon Titan, and Pluto. These volcanoes are especially active on Io, which has hundreds of vents. NASA vehicles have even captured some of these erupting in real time. Plumes of frozen vapor coming out of them extended for about 250 miles. Hey, by the way, they just discovered another moon around Jupiter that might actually be good for farming someday. It's named EIEIO. Now, what exactly happens to the light after it disappears inside of a black hole? Well, photon is a particle of light. The event horizon is the boundary of a black hole. When something, say a photon, crosses the line and enters those boundaries, it can't escape anymore. But it doesn't mean a black hole destroyed it. It pulls the photon in rapidly towards its center, where an enormous mass is packed into an infinitely small space. But we're not sure what happens to photons in such extreme conditions. It's still one of the biggest mysteries. Does a black hole destroy the light or not? Saturn has 82 moons we know about, 53 confirmed and 29 more that are still on the waiting list to be confirmed as actual moons before they get their official names. And one of the coolest moons might be a 914-mile-wide hunk of rock called Iapetus. It's dark on one side and bright on the other. Its lighter half is 20 times more reflective than the other one. As it turned out, the bright side is ice. The dark side is a bit more complicated. One theory says it's dark because of particles coming from another moon, the one named Phoebe. Another theory says it could be because of heat. Since the moon is rotating really slowly, its dark material is absorbing heat, which makes it even darker. Now, how big do you think a black hole can become? In theory, we can't find an upper limit to its mass, but astronomers believe the ultramassive black holes, or UMBHs, located in the cores of certain galaxies are mostly up to 10 billion solar masses big. Recently, they even discovered these UMBHs physically can't grow much more than this, because, in that case, they would start to disrupt the accretion disks that feed them. That way, they would kind of stuff the source of new material. Most people picture the universe as somewhere between aquamarine and pale turquoise. Even some researchers thought that was the case. They managed to determine the cosmic color by combining light from more than 200,000 galaxies within 2 billion light-years of our planet. But the real color is actually closer to beige. Researchers got it all wrong because there was a bug in the software. No, really? It converted the cosmic spectrum into the color our eyes would see if we were exposed to it. The team defined this color as a cosmic latte. Ooh, make that a double-shot low-fat large to go, please.
I'm about to introduce you to a place where the laws of physics take a vacation. Welcome to the mystery spot, where you can witness all kinds of implausible things that will leave you scratching your head in disbelief. Don't worry, it's not sorcery or witchcraft. It's just some clever optical illusions that mess with your brain and make you question reality. Back in the day, when the Great Depression was hitting hard, people needed some fun distractions. That's how the entertainment industry gave birth to the concept of mystery spots. One of the most famous mystery spots is the one near Santa Cruz, California. The name is all intrigue and mystique, isn't it? Once you step inside, you'll see people standing upright on a slanted floor or at impossible angles on a flat surface. You'll see a ball rolling up a ramp defying gravity and logic. It's like being in a fun house but without creepy clowns. The site is known for its gravity-defying demonstrations, which appear to bend the laws of physics, both on the short uphill walk and inside the wooden building on the site. Misperceptions of the height and orientation of objects occur here. These visual illusions include balls rolling uphill and people leaning farther than normally possible without falling down. Psychologists at Berkeley state that all of the misperceptions stem from the simple fact that the house is slanted at a 20-degree angle. The next stop is again in the USA, but this time at Hoover Dam in Nevada. Here, gravity seems to play with us too. Try this experiment if you ever happen to go there. Pour water from a bottle over the dam. You will witness that instead of going down, the water will start flowing upward. The reason behind this is a very powerful updraft that the structure of the dam creates. In other words, the water gets carried upward by the wind. This trick is not unique to the dam, as there's a reverse waterfall in the Faroe Islands. It occurs due to a wild weather phenomenon known as an inverted waterfall. Imagine a gigantic whirlwind of ocean spray swirling up a steep, 1,542-foot high rocky cliff. So how does this crazy phenomenon happen, you ask? Well, it's all thanks to a spiral column of air that rotates near high and steep cliffs, creating a mini tornado effect. And when the wind hits the edge of the cliff, it gets even stronger and picks up coastal water, which then splashes up the cliff and creates a massive water and wind funnel. Apparently, these inverted waterfalls can happen in other places too, like on the cliffs of Moher in Ireland, the mountains of Iceland, and even in the Waipuhia Falls of Hawaii. Talk about Mother Nature showing off her skills. Magnetic Hill in Ladakh, India? The ultimate mind-bending road trip destination? Here, you can watch objects and cars roll uphill like they're stuck in some kind of magnetic vortex. It's an optical illusion that occurs thanks to the sneaky slopes and general layout of the area. The road might look like it's going uphill, but it's actually a downhill road in disguise, playing tricks on your brain like a mischievous magician. You might also see your car moving by itself in the neutral gear. No, your car isn't haunted, it's just basic physics at work. Even when the engine is off, the wheels can still turn, thanks to momentum and the subtle slope of the road. Mount Aragats has a similar story to the Magnetic Hill of India. This one, too, is like a magnet for thrill seekers and car enthusiasts. It's located on the border between Turkey and Armenia. It has a reputation for making cars defy gravity. People from all over the world visit this mountain to witness the incredible spectacle, where a car parked on the slope seems to roll uphill all by itself without any driver behind the wheel. There's a nearby river that flows uphill too. People who visited this site claim that it's easier to go up than down there. Number 6 on the list is the Golden Boulder from Myanmar. The rock looks like it's about to tumble down the hill at any moment, but it's not going anywhere. It's been sitting there for over 2,500 years. The rock is the centerpiece of a stunning pagoda that sits on top of it, towering 49 feet above the ground. According to legend, the rock is held in place by none other than a strand of Buddha's hair. It's no wonder that this place is one of the most important Buddhist pilgrimage sites in Myanmar. The rock was chosen by a celestial king who was impressed by a Buddhist monk's incredible asceticism. So, he used his supernatural powers to carefully place the rock in its current spot, where it looked like the monk's head. If that's not enough, it's said that only a woman can move the boulder. That's why women aren't allowed to touch it. So, if you're up for an adventure, head over to this magnificent rock and pagoda and witness this gravity-defying feat for yourself. Back to the US. Oregon Vortex is located on Sardine Creek, Oregon. It's a tourist attraction that's been around since 1930. The owners of the attraction claim that it's some paranormal activity, but it's pretty obvious some clever optical illusions are involved. Legend has it that even before the attraction was built, Native Americans in the area warned that this land was forbidden, and horses refused to go there. But then, some gold miners built an assay office there in 1904, and the building ended up sliding to a wonky angle. Now picture this. You're in a cozy spot, away from city light pollution, staring up at billions of stars putting on a sparkling show above you. But if you're lucky enough to be in Marfa, Texas, you'll get a little something extra. Mysterious orbs decide to join in on the fun, shining bright like a diamond, and they've been doing it for over 100 years. But what are these glowing orbs called Marfa lights? Well, everyone has their own theories. Some people think they're just car lights from the nearby highway, but that's no fun. Others believe that these orbs are actually sentient beings trying to convey some sort of important message to us, mere mortals. Imagine standing at the edge of a stunning lake, admiring the picturesque view of a majestic volcano. Suddenly, you hear a loud boom and flames shoot up into the air like a fireworks show gone wild. But don't worry, it's not an eruption, it's just the Kauai'an Lake and volcano doing its thing. This fiery spectacle is caused by a natural phenomenon where sulfuric gases burst through the rocks and ignite upon contact with the outside air. The result? Flames that soar up to 16 feet in height, burning blue like the coolest neon lights you've ever seen. And if that's not enough, the liquid sulfur that streams down the mountain looks like a molten river of electric blue lava. It's equal parts terrifying and breathtaking, and a sight you won't soon forget. Speaking of unforgettable things, the Richat structure in Mauritania has been an eye-catching enigma for astronauts since the dawn of the NASA space program. This circular feature in Earth's crust was created by a raised dome that was eroded over time, revealing the original flat rock layers. As you move from the center of the structure outward, you travel back in time, as the older rock layers are exposed in the middle. This geological phenomenon is made up of sedimentary and igneous rocks and measures 28 miles across. From space, you can see several faults where the rock layers have shifted and have been pulled apart. The Richat structure is situated in the heart of the Sahara Desert. There you go. This is our version of the top 10. Would you add something else to this list?
Ah, beautiful! You're walking with your friend and look up at the sky. The sun looks a bit different today, like it has some kind of ring around it, a rainbow type thing. Huh? Hey, look at that! Your friend pulls his head up out of his phone. You shouldn't look directly into the... Stop everything, he says. It's a sun halo. We need to find shelter now, unless you have the world's biggest umbrella on you. A sun's halo is nature's sign that there's a snow or rainstorm on its way. It's caused by clouds that are made of bazillions of small ice crystals, flying around 20,000 feet. Sunlight goes through those crystals, which causes the light to split and refract, like when there's a rainbow. Now, don't look at the sun halo directly. It's going to be tempting because it's not something you see every day. Plus, it's really beautiful. But ultraviolet light can burn the exposed tissue of your retina and cause serious damage. So, not worth it. Grab some sunglasses and you're good to go. This phenomenon lasts about 40 minutes. These clouds are the same ones that can cause a spooky ring around the moon at night sometimes. Nature sends early signs of disasters in many ways. J-shaped trees means there's a landslide coming. Since the ground is moving slowly, the trees grow into the super selfiable shape. Try to find a flat area and avoid going near any trees, unless you have superhuman strength. You're on a nice walk on the beach. Sand, sun, not a cloud in the sky. Then, out of nowhere, you see the ocean going back away from the shore. Suddenly, you can even see bits of coral, small fish, and other random small sea animals. That's a good sign to leave. There might be a tsunami on the way. A tsunami is formed when there's an earthquake underwater, and it can hit the coast at 500 miles per hour. It's mostly a Pacific Ocean thing, but why risk it? If there's a channel of choppy water on the beach, stay away. There might be a rip current under the surface that can be extremely dangerous. Sometimes waves hit the shore in a weird way, which forms these rip currents. You might see a strange gap in the waves, Or you might notice random bits of seaweed going in all different directions. If you don't ever find yourself caught in a rip current, try to stay afloat and don't waste your energy swimming against the current. Yell out for help and try to float your way along the beach. Once you break out of the channel, swim diagonally to the shore. If you find yourself in the ocean and see a group of sharks swimming, okay, this scenario doesn't sound good either way. Well, the good news is they're not necessarily coming for you. The bad news? The sharks might be trying to escape from a huge tropical storm or even a hurricane. Sharks can sense these things, so when nature gets angry, they group together and swim deep under the surface to get to safety. You probably shouldn't follow them. Good luck! The golden rule since ancient times: follow the animals. Insects, rats, and snakes leave their homes a couple of days before really big earthquakes. Scientists can't track or really explain how they know it's coming. It seems animals really can sense earthquakes, maybe because they feel those smaller initial shock waves that we don't even notice. What if you see animals running towards you? Well, that could mean you're about to get eaten for breakfast. Or it means there's a wildfire behind them. Amphibians like frogs, toads, and salamanders try to protect themselves by burrowing down into the ground. Others just run. Before you start running alongside them, check to see if you can see smoke. You don't want to sprint flat out for nothing. Well, it's not just animals. We can spot warning signs too. For example, if you notice your hair suddenly starts to stand on end and your jewelry starts to buzz, take shelter right away. Lightning might be about to strike somewhere nearby. If you're outside and can't run into a house, make sure not to stand near any tall structures. Lie flat on the ground. Be near water. Seek shelter under an isolated tree or stand in an open space. And don't stand on top of the Empire State Building. That thing gets zapped hundreds of times a year. Do you like skiing? It's all fun and games until all you can see is white. Avalanches can move up to 80 miles an hour, so watch for some warning signs. Does it feel hollow when you walk in the snow? Are there cracks around your feet? Can you see a huge avalanche coming? Time to go! Sometimes a storm mixes its blue light with the red light from the sun, and you get a pretty impressive green. Enjoy it from a safe distance, preferably indoors. This super tall thundercloud usually means you're about to get smashed by hail, or worse, a tornado. Find cover somewhere, like in an underground parking lot or a basement. It might be a bit embarrassing if you're wrong, though. Okay, we know volcanoes can be dangerous, but the lakes near them? Is anything not a sign of danger? Lakes that are near something boiling hot that never cools, so volcanoes, are like wildly shaken soda cans, just about to burst. The magma that's underground actually pushes carbon dioxide into the bottom of the lake, and that gas stays there, waiting. Then, even something boring like rain can disturb the lake a little too much and bam, or boom! You get the picture. Diving, swimming, snorkeling, the sea can be amazing, but it's pretty unpredictable. When two wave currents run into each other, they can create a cross sea. It looks pretty cool from far away, but it can be really dangerous for swimmers, surfers, or even ships. There's a strong current roaming around under the surface. You're walking on the beach, apparently every good story starts like this, and all of a sudden, ooh, a cave. How cool is this? You should probably go in there, explore a bit, and no. If there's a full moon out, you might not be able to get out of that cave. A full moon affects the tide and makes it lower than usual. That cave might be more accessible, but instead of an exciting adventure, you could end up trapped in there until the next full moon. Bring a big lunch. A wall cloud is one of those things you're both excited and scared to see. Scared because you don't know what it is. Excited because, well, how often do you see something like that? Whatever you feel, tell your legs to start running. During a thunderstorm, these wall clouds sit lower than anything else and can be up to 5 miles long. And if they start spinning, well, Dorothy ended up in Oz. Who knows where you'll end up? It's 2009 in Italy. A man was hanging out in his kitchen. Then he saw some flickering lights. He knew just what to do. He moved his family to a safe place. A couple of seconds later, a massive earthquake hit the whole region. His family survived thanks to his quick reaction. He knew these flickering lights were actually a sign of an upcoming earthquake. People have been seeing these mysterious lights for ages. Some thought it was some kind of sign coming from space. Scientists never used to take them seriously, but after the invention of photography, more and more evidence of these strange lights appeared. Soon, they realized the connection. The lights appear, and pretty soon, the earthquake hits. After a bit of digging around, they actually found some records of these earthquake lights from hundreds of years ago. There were bluish flames coming out of the ground right before an earthquake. Ooh, creepy. Oh, ocean, come on, not you again. Okay, but just one more. If you see the oceans turned all reddish-brown, don't go in the water or anywhere near it. This red tide is caused by toxic algae and is something you can find all over the world. That toxic algae can be there even if the ocean's a normal color. Getting that stuff all over you can cause some health issues. Rinse yourself off in fresh water as fast as you can. You know, they even wrote a holiday song about it. Algae Home for Christmas. No, really. Hey, you're running through a vast field at night, as if something is chasing you right now. The light of the full moon brightens your path, and you see a circle of light around it. You run on looking for a safe shelter. It's not about werewolves, who are said to appear when the moon is full. Soon, this place will be the epicenter of a major storm. This very circle around the moon is called a halo, and ice crystals cause it in the sky. When the moon is full, it reflects a lot of sunlight. These rays then pass to the Earth's surface, but they curve their trajectory and split as they pass through hexagonal ice crystals. As a result, we have a halo of different colors, almost like a rainbow. The inner edge of the halo is red and the outer edge is blue. It looks beautiful, but the presence of ice in the clouds means this ice will soon turn into water and begin to fall to the ground. And this rain will be so heavy that you'd better find a shelter beforehand. If the weather is quite warm and the clouds are closer to the ground, you might see a similar phenomenon, a corona. It's much smaller than a halo, but much more colorful. The bluish-white disk on the inside turns brownish-red on the outside. Unlike halo, the corona is made of water droplets. The smaller these drops are, the larger the corona will be. If the water droplets are large, the corona will look like a bright spot the size of the moon itself. Both the corona and halo might also occur during the day when the sun is shining. But be sure to wear sunglasses before just glancing at it, because it's very bright and really bad for your eyes. As soon as you find a shelter, it starts raining heavily. Whoa, what is that? Are you being photographed? No, the flash you just saw is lightning. Bam! Thunder is so strong, the windows in the house start to shake. Here's a tip on how to tell if you're far away from the epicenter of a thunderstorm. When you see lightning, start counting. 1 1,000, 2 1,000, 3, and so on. When you hear the thunder, stop counting. Now you have to divide that number by 5. If you can count to 5, it means the epicenter of the thunderstorm is 1 mile away. If you didn't find a shelter before the thunderstorm started and it caught you in the open, leave the high ground immediately. Any mountain or hill is a high-risk area. Don't even think about hiding under a tree. Tall objects are the first target for lightning. Power poles are also at risk. If a thunderstorm catches you riding a bike, drop it immediately and run away. Same if you were riding in a convertible, golf cart, or motorcycle. If a thunderstorm started while you were in an open field, the tallest object here is you. Get down and try to cover yourself somehow. If you're not alone, try to keep your distance from each other. Whew! Now let's admire the beautiful sunrise. It looks like someone spilled red paint on the sky. This beautiful view means it's about to start raining. You can see a red sky at sunrise because the high pressure zone has just passed you by and is now followed by a low pressure zone with high water content in the air. So take an umbrella with you or go back to a warm bed and stay indoors. There's an old saying to keep it all straight. Red sky in the morning, sailor take warning. Red sky at night, sailor's delight. Sometimes you can even predict rain by smelling it. It's all about ozone molecules. Storm currents bring ozone down from the upper atmosphere, and when the storm is about to start, you can smell a sense of cleanliness. It's like you just washed the floor with clean water. Your sense of smell gets more sensitive before it starts to rain. It's not because of your nose, but because of the more humid air. Flowers spray their scent, and the water molecules stick to it, spreading it much better. That's why the same flowers smell different when you smell them outside or in a closed, humid greenhouse. Plants can also help you predict changes in weather. If you touch the grass in the morning and it's wet, it means it's going to be a clear day. That morning water on the grass is dew. It appears at the coldest time of night. Clear skies allow the earth to cool a bit, and the water vapor molecules in the air turn into a liquid that settles on various surfaces. Take a closer look at the leaves on the trees. Sometimes they can be upside down. For example, maple leaves respond well to increased humidity before the rain. Their stems become very soft, and the wind can turn them upside down. But the best indicator is pine cones. The seeds are inside the cone, just under its scales. The pine needs to keep them as dry as possible so that the wind can carry the seeds far away and new trees can emerge from them. So when the pine senses rain approaching, it gives the order to close the cones. Then the scales close, protecting the seeds from the water. And instead of boring weather forecast hosts, you can just follow the animals and insects. Have you heard the crickets chirp? That will be your thermometer for today. Set the timer for 15 seconds and count how many times crickets chirp. Add 37 to that number and you get the outdoor temperature value in Fahrenheit degrees. All because air temperature directly affects crickets' metabolism. It can chirp slower and faster depending on how warm it is. So throw away your thermometer and get yourself a little friend. Now, if you don't like insects, look up into the sky for birds. If they're flying high, it'll be a clear and sunny day. But before it rains, air pressure prevents birds from flying high. You may see them flying in flocks very low, most likely looking for shelter. So even if the sky is clear, air pressure tells you that rain is coming. If you live near a river or lake, you can hear toads singing, although you can't quite make out the lyrics because it's in toad. They are especially loud before it rains hard. Toads, in general, love wet weather, so they just get excited. Rain is also the best time for females to lay eggs, so they scream loudly in search of a guy to wed. Ow! A mosquito has just bitten you. If mosquitoes are being especially aggressive, you better find a shelter fast. The insects are just trying to eat more before they have to starve during the storm. Also, the warm, humid air makes us sweat more, and we become even more attractive to mosquitoes. Insects also gather in swarms before a thunderstorm. They love the moisture in the air and start circling in a dance. But then they vanish into thin air. It means you have 1 hour left before heavy rain starts. To predict the weather for the next day, you need to watch the bees. If it rains tomorrow, the bees work overtime. They're pollinating flowers actively because they know they won't be able to leave the hive the next day because of the rain. Squirrels can predict the weather for the whole season. They usually stock up on food for the cold times. And if they start doing it early, it's going to be a tough winter. You can see squirrels running around looking for acorns. They hide them in the ground and run to find the next one. The squirrels often forget where they hid their food. These acorns turn into little sprouts, so we have many new trees, all thanks to squirrels. Animals can also predict disasters like earthquakes. Scientists once did a study in an area with frequent earthquakes in Europe. They put trackers on cows, dogs, and sheep. About 18,000 earthquakes occurred there during that time. Most of them were insignificant, but there were also 12 with a magnitude of 4 on the Richter scale. And each time, before the earthquakes, researchers recorded strange animal behavior. It was as if they were trying to escape from the earthquake zone. Scientists believe animals can sense the ionization of the air before a disaster with their fur. Their good sense of smell also allows them to smell gas. It comes from moving deep underground and then trying to find its way out through small cracks in the surface. The first records of such animal behavior date back to ancient Greece. Cats, rats, snakes, and centipedes left their homes and fled to safety days before a major earthquake hit Greece. Some fish can predict the weather in the area. If sharks hang out near the shore, they're not necessarily looking for food. They may be hiding from a big storm at sea. The worst sign on the coastline is when all the water starts to go back abruptly. You can see the entire shoreline and even the fish and coral that are left on the land. Run away immediately, because soon a huge tsunami wave will come here and wash everything away.
You decide to go out for a morning jog for the first time in your life. You put on your headphones and get ready for something hard and unpleasant. But as soon as you go outside, you feel an extraordinary lightness. At first, you enjoy it and speed up, but then you realize that something's wrong. You're running too fast and too easily. You feel like you've just taken off a heavy backpack that you've been carrying all your life. You're so fast, you think you must have a superpower now. But you notice another athlete running as quickly as you. You notice a puddle ahead of you and jump over it. You jump so far and so high, it feels physically impossible. You fall to the ground, shocked. Then you notice there are no scratches on your body, and the ground feels lighter. You stop the music in your headphones and turn on the radio. All the news reports say the gravity on the entire planet has decreased by half. Thanks to gravity, we stand on the ground and don't fly away into the sky. This power allows our planet to revolve around the sun and the moon to revolve around us. Heavy things seem heavy because of gravity. And now, something has happened to the Earth's core, and the mass of our planet has decreased. This is the reason for the change in gravity. People happily run out of their houses and jump twice as high and further than they used to. Any objects seem twice as light to you. Your body has become lighter, so you can easily stand on your hands. But still, you don't feel like a superhero. You can't lift a car, even if its weight was reduced by half. But now, parkour is easier for everyone than before. Your body's weight has decreased, which means you get less damage when you fall. However, panic quickly replaces the joy of the new conditions. It becomes hard for you to breathe, the same as all other people. The air has become lighter. The updated force of gravity has reduced the air pressure by half. Now you feel like you're at an altitude of 16,500 feet among the streets of a usual town. It's like you're halfway to the top of Mount Everest. The air is no longer as dense, and the main part of it has settled in the atmosphere. In the beginning, everyone experiences massive dizziness and panic. You feel like there's not enough air in your lungs, so you get nervous. To solve this problem, you have to learn to breathe slowly and evenly. Thanks to this, you calm down a bit. Others also learn to be more balanced and don't live in a hurry anymore. All of you experience less stress and enjoy every day. Then scientists create unique oxygen masks. You put it on, take a breath, and a special filter puts pressure on the oxygen molecules, making the air denser. After a couple of decades, people will take off these masks as they'll ultimately get used to the new conditions. New generations will be born with adapted lungs. The Earth's atmosphere is expanding. It seems the sky has risen higher and acquired a darkish hue. Satellites flying around the Earth's orbit are now inside our atmosphere, but the Earth's gravity still attracts them. You see thousands of satellites burning up. Some of the space debris survives the atmospheric shield and falls to the ground. A meteor shower begins. Space trash crashes into houses, roads, trees, and cars. You and the rest of the people decide to wait out the storm underground, in the subway or basements. Fortunately, the shower doesn't last long. People come out of their hiding and look at the sky in surprise. The moon changes its previous position and slowly flies away. Soon it disappears completely. Our planet is now like a heavy ball in the center of a huge blanket. That blanket is gravity. It bends under the ball's weight. If you put any light object on the blanket, it will roll down to Earth. But if an object is moving at high speed, it will be able to spin on the blanket's edge and not fall into the center. Thanks to such speed, the moon doesn't fall on us, but at the same time, it can't fly away. Now that gravity has decreased, the blanket has become twice as loose. The rotation speed allows the moon to fly out of our gravitational field. It just goes into space. People will be able to observe the wandering moon for a long time through telescopes. Meteorites might crash into it. It could also find another planet with stronger gravity and will revolve around this new home. The moon may stay in place, but will be revolving around the Earth at a slower speed. In any case, there will be no more tides on our planet, and the sea level will remain the same. In the sea, you can also feel the changes. It's much easier for you to stay on the water, and you can swim faster. But the coolest thing is running along the shore. The splashes are floating in different directions, so slowly and beautifully. The waves are running on the sand in slow motion too. The weight of cars, planes, and ships has reduced, and so people consume less gas now. You can drive twice as far with a full tank. Fuel transportation is easier, and less energy is spent on flights. Gasoline is becoming cheaper. The decrease in gravity inspires space tourism development. It becomes much easier for people to fly out of the Earth's orbit. Winter has come. You're walking down the street during a snowfall. It seems to you the snowflakes are stuck in the air as they're so slow. You step on the ice and realize that it's almost impossible to walk on such a slippery surface. Your weight has decreased, and the pressure of your feet on the ice is twice as weak. You're sliding and can't stop. You often fall, but you don't feel any harm. When the wind is strong, it's hard to stay on your feet. If you jump, you may even fly away. The grip of wheels on the road deteriorates. A driver can no longer brake abruptly. The wheels don't spin, but the car continues to slide for a while. That's why new speed limits are being introduced all over the world. You can still enjoy extraordinary strength and long jumps, but after a few generations, the human body will evolve and fully adapt to these conditions. People and animals will be born taller and bulkier. Majestic tigers the size of a truck are walking through the city streets. Flamingos the size of a plane are flying in the dark blue sky. But the worst thing is that the size of insects has increased too. A regular cockroach can now grow to be the size of a computer mouse, and tarantulas become twice the size of an adult palm. At the same time, all living beings become lighter in weight. Humans will become elegant and agile creatures. Our bones and muscles will stretch. The structure of the entire human body will change. We'll become thinner and smoother. Blood in the veins and vessels will flow more slowly, and it will greatly impair the brain's work, but only in the beginning. In the future, the body will expand. The brain will increase, as will the number of neural connections inside. The lungs will become more sensitive and spacious. People will be smarter and wiser. All devices and materials will be developed according to the new conditions. A cup, a pencil, a plate, phones, and other gadgets. Everything will get lighter and more fragile. If an ordinary person gets into such a world, they'll feel like a superhero. You'll be able to punch through lightweight walls and doors and break bricks with your hand. New people won't match your power, but you'll seem too small and clumsy to them.